if everybody is settled, then we would like to start the celebrations of brilliance of our engineers. Okay? So to the chief guest, Mr. Amit Chaudhary, sorry, and Mr. our beloved President, Shraddha sir, and my dear colleagues and friends. My name is Pawan Kumar, and on behalf of organizing committee, we warmly welcome you to the 4th edition of Vipassana. So before we walk through the agenda for today, we would like to honor our chief guest who humbly accepted our request to be the part of our annual innovation conference. I request my colleague KJ Suni to hand over the Lucky Bamboo Bonsai plant to our chief guest.
Bharat.
Yeah, Vipassana is an entrepreneurial initiative to identify enterprising ideas across all divisions of the group. Now the value is not in just offering the new product, but to identify and encourage innovative ideas among all employees, that will establish HBL as the first choice for its products. And so coming to the agenda, like every year we received enormous registration for the current year also. After stringent filtration, today we have 16 presentations to be witnessed, which our engineers are going to present during the day. In 16 PPT mode and 6 presentations through So we will try to close the presentations by 4:30, and we will have a small break for every 2 hours. Hope everybody has taken a note of the sequential order. So the ground rules for the participants are like this, Each presentation will have 30 minutes, in which 20 minutes for their presentation, for presenting their idea, and 10 minutes for question and answers. We will give a reminder buzzer after 15th minute and the final buzzer after 20th minute. There will be negative marks if any participants crosses 20 minutes, and that will depend upon the sole discretion of our chief guest. And for the poster presentation, each participant will have 5 minutes to present their idea. So I request now to keep your mobiles in silent mode so nobody can be disturbed. So let's see how our engineers will stress innovation today during the course of the day. Yeah. Now I will call my colleague Mr. Pradeep to give a recap of last 3 Vipassana winning ideas and their present status now.
Good morning all. Once more, good morning.
Good morning.
That's good. Thank you. Thanks Pawan, and as Pawan mentioned, this is our 4th edition. We have been in business since 2020. So we have been successfully hosting this every year. There have been a lot of innovative ideas which came in and which have been implemented and they are in force as well. Some of them are in force, some of them are yet to be, and we have been planning that, and probably in this year and next financial year we will see them in force as well. So let's quickly walk through who all have been the winners and what we have seen in previous years. So first edition 2020, we have for the first edition, we have our chairman, Dr. A.J. Prasad, as our jury, our chief guest, and let's see. Yeah, okay. So the first award was to Tirthankar. Is Tirthankar in the room?
Yes, sir.
Oh, there you go. Right. So this was one of the first ideas which got the chairman's award. It's like electronic control of conventional design engine in a hybrid electric drive. So the current status is like the functional test was conducted successfully in Tata 1613 CC engine, and then concept is functionally verified by installing a PMSM inline to vehicle propeller shaft. So this in the recent time, electronics group focus actually shifted to pure electric drives for urban transport. But the idea was well taken and it was proven as well. Parallel hybrid vehicle project is on standby and would be taken up when we shift the focus back into intercity transport. Right now we are mostly working on the intracity transport. So thanks Tirthankar for that. The first runner-up was a Unity Power Factor thyristor battery charger, and we have Srinivas Baka and his team in here. Yeah, the methodology for achieving the objective is identified. This method is primarily used in thyristor-based chargers. But again, eventually HBL has planned to shift the focus again from thyristor-based chargers to IGBT and MOSFET-based chargers. So right now, I think this is kept on hold. But the idea was well taken, and it was awarded the first runner-up. And second runner-up, and that's me, you can see on that. This is Panorama. And along with me, we have a joint winner, that's Ramesh Kalla. He is not with the company as of now. We have, this is for Panorama. Panorama for TCAS. Train Collision Avoidance System is one of the flagship products for electronics group right now. So this was something where we tried to develop while we have all our products in the field to identify if there are any failures, so that remotely we can actually know what is the status of our TCAS systems in the field. And also, so this was the first version what we did. This was completed, and then it was already in use from April 2020. We further enhanced this to CRM as a CRM, basically customer relationship management solution, where we can capture all the failures and then do some preventive maintenance as well. This was the second 2.0 version of it, and this was again in use since 2022. And we continue to improve this product, and because this will be one of the most used products as we move forward, and as we have more and more installations. So we are now enhancing the product to a chatbot concept on this, where you can have your FAQs. So we have a lot of field engineers, service engineers in the field. Not everybody may be knowledgeable about the product, and if they want to know what's going on, so we have right now, you see in many of the portals where you have this chatbot, right, ChatGPT. So if you know, so you can it keeps asking you questions, and then it comes out with an answer for you. So this is the concept we are trying to implement this, and this is we are building it right now, and we should soon implement this within a couple of months. This is about Panorama, and then second runner-up joint winner is again the test automation and digitization is what we did for all our TCAS products. This is basically a configuration management system. So every product, every TCAS system which is going out in field, okay, that needs to be traced back to each of its components within this. So there are hundreds of components in TCAS system. So all this is being maintained at one stop, which is this configuration management system. So it has been completely configured. I mean, we can trace out at any point of time, so and so location, so and so system has what are different kinds of configuration, and what are the different kinds of hardware, software which has been used. So all that can be traced by using this system. This has been also in use for a long time. For all the TCAS contracts, we are using this right now, and we are also, right now this has been taken care by Mr. Subramaniam, and he is also looking forward to extend this to all other products as well. You want to add anything? No, good. Okay, that was for 2020. Moving forward to 2021. Chairman's Award. This time we have Julie as one of the IIT Kharagpur's professor. So the Chairman's Award again goes to Ram and Rakesh. Both are not with HBL as of now. So they have developed improvement in torque density of switch reluctance motor. So they came up with 3 different concepts, and the design concept 2 was implemented and has been proven to be effective. So a 50 kilowatt motor was ICAT certified as well. So we have implemented this in a 50 kilowatt motor, and it has been certified by ICAT last year. First runner up, E5 LS SYRM motor for industrial application, again Srinivas Baka and team. Yeah, the prototype model of i4 motor is developed and tested in lab successfully. However, it was realized that this model cannot work in high inertia loads for industrial applications. So due to the limited addressable market of low inertia loads, this product line is right now currently dropped. So we are not looking forward to work on this product. Second runner up, quick BOQ estimator for TMS and TCAS tenders. So this was one of the initiatives by our sales team. Varun City, you can see in the picture, he is our there you go. So he's our sales general manager, and that's PV Ramana, and this is VK Narayan in our Eastern Railways sales executive. So they have come up with this idea for BOQ estimator for TMS and TCAS. And TCAS we have already developed. This is being used for all the tenders. So it is in force, and they are planning to work on TMS also similarly. So this is still in progress. We have not come up with. They have been too busy with TCAS. So we have PV Ramana in the room. No. Okay. Yeah, that's for the second year. And then we have for 2022, this is the last year's presentation. The chairman award again goes to Ram and Akshay Patil. And Satish Patil, sorry. Akshay Patil and Satish Patil. So again, they developed this thermal management system. So this was developed based on the second law of thermodynamics. This was implemented successfully in our current EDT kit design. Chairman's award was actually shared between two of them, and the multi-phase SRM and its advanced control. This is again the same three people. Again, this was implemented for direct drive SRMs, tested successfully in 7.5 ton light commercial vehicles. The first runner-up, multi-speed gearbox for electric vehicles. The current status is this is proposed for new motor designs and to be taken up in FY24. So this is Siddharth Mahesh and Joji Matthews. Is Siddharth Mahesh there in the room? Yeah. That's my last year. Alright, that's all from me. Any questions to the winners here? No? Okay. Thank you.
Now I would like to invite our chief guest and our president to do the lamp lighting to start the fourth edition of Vipassana. I also request Ushamana and Tejaswi to join. Yeah, ladies. Thank you, sir. Now I would request our President, Mr. Vipassana sir, to give the opening speech.
Thank you. Pawan said it's an opening speech. It is not an opening speech. I just want to talk. Right? So, we are running out of time. I'll probably take about 2 minutes. There are a number of new people here since 2020 when we first started Vipassana. So, my intention is to tell why we started this in 2020, why we started, how it all began. What is the reason for this innovation conference that we are having every year. So before we go there, there are 4 logos. Each organizing committee every year have been coming up with a new logo. So I just wanted to show all the 4 logos. The energy of the teams is also going not only into organizing the event, but also into designing a good logo and using that logo consistently in all the communications. So the attention to detail that the team is going through for all activities around organizing the event is something that caught my attention. So I thought I would share this with all of you by putting all the 4 logos. Every year they come up with a slight variation of the logo. Now what is Vipassana? This is a word that many of us do not understand it very well. So I thought I'll have a few words about what Vipassana is about. Now if you see this picture, there are many ways of looking at the object in the picture, right? Many ways of looking at it, and if you look at it in one way, then you will see that rectangular or a square box, right, with the orange color halo around it. That is a true representation of what the object is about. So that is true. But if you look at it on the other wall, you see a circular object with a bluish halo around it, and that is also true, right? But what is the truth is different from what is true. There can be many things true about that object, but the truth is that it is a cylinder, and you need to look at it from a perspective. Then only you will understand that it is a cylinder. If you look at it from any other perspective, you will see some truth, but it is not the whole truth. Okay? So, I wanted to use this word Vipassana to make us understand that this is about the skill to see things as they are, not as we want them to be. Okay? It is the state of insightfulness to realize the reality of life. Now, how is this relevant for engineering? How is this relevant for business? From an engineering point of view, I find it very interesting that almost everything that we discuss in technology development, product development, can be ultimately explained by the fundamental laws of physics. Whether it is the Newton's laws of motion, or the Farade's laws of electromagnetic induction, or Boyle's law. We are talking about Archimedes' principle just when the conference was beginning, right, Srinivas? So almost everything that we talk about in business or in engineering, product development, technology, process, manufacturing, all of them can be seen at the most fundamental level of the laws of physics. And if we are able to see them, visualize these things at that level, we are at Vipassana. We are experiencing Vipassana if we do that. So my intention is that we have to see things at that level, and that's the reason why in 2020 when we started this innovation conference, we gave the name of Vipassana. But how it all started? I read this article on the MIT Sloan Management Review, this journal comes every month. And I read this article on the 12 different ways for companies to innovate. I think it was a 10-page article. I got it from Dr. Prasad. He was an alumni at MIT, so he sent me this article and I read it. And I found it very interesting. The article talked about those 12 dimensions of innovation that most businesses experience. Basically, businesses have 4 things to do. Okay? They are on the 4 corners of the vertical and horizontal axis. Okay? So businesses have offerings, what they sell to the customers. Then the other point is who they sell to the customers. Then the processes, how they sell, how they manufacture, how they deliver, right? And then the 4th one is the presence. Where they sell to the customers, where are the customers existing, where are these products and services sold, delivered, etc. And in between we have things like, when we want to say we offer something, what do we offer? We offer either a platform or a solution. Platform is a portfolio of products and solutions. Then to whom we sell, customers, they experience our products and then they allow us to capture value. Because all businesses, they thrive on value delivery and value capture. When we create value, that value has to be shared with the customers. So customers pay some money and we also deliver some value to the customer. When the value is created, it is shared between the customer and the business. Right? So how much of it we capture, how much of it we allow the customer to retain, depends, on that is the success of the business depends on. Right? Then in terms of the processes, how, then we need to organize ourselves. There is an innovation around how we organize our businesses, right? And how we manage supply chain. Right? These are two areas where innovation is possible. And in terms of presence, where we are present and how we deliver our products and solutions, the two things that are relevant are how we network with our suppliers, with our customers, with our partners. So networking and then creating a brand identity for the organization. There are many things that are relevant from a brand identity point of view that have a bearing on the success of the business. So innovation along these 12 dimensions is what this article was talking about. And I realized that we do a number of things. We do a number of things along these 12 dimensions, but they don't get the kind of attention in a forum like this all the time, right? So that's when I thought that we should have this kind of an event every year where people get the opportunity to present what they are doing and communicate. The purpose of this event is to communicate and obviously also to get recognized, right? So that is the reason why we started this in 2020. I'm glad that it has been organized every year for the last 3 years, and this is the 4th year. Why we should do this is because if we are focusing only on one dimension, let's say we have good products, the features of these products can be very easily copied. Somebody else will do it, right? And if we are manufacturing at low cost, somebody else can also manufacture at a lower cost and then compete with us and take business away from us. But if we innovate along many dimensions, if we enlarge the area under that red color polygon, then we are increasing our competitive advantage. It becomes difficult for competitors to copy what we are doing, right? So the objective of the Vipassana event or the multidimensional innovation is to increase our competitive advantage and become sustainable. So it will be very difficult for others to copy how we are doing things. So that was the rationale for the Vipassana and how it all started. So for many of the new people who are here today, right? Then I take a moment to introduce today's jury, Mr. Amitabh Chaudhary. He had been a good friend, philosopher and guide for HBL. We have been working with the organization that he set up, Type 2, for the last 7 years or something like that. Okay, I've been knowing him since then, and we have a very tacit affiliation with IIT Kharagpur. Dr. Prasad is an alumni of IIT Kharagpur, and Professor Mukhopadhyay, who had been the jury at Innovation at Vipassana 2021 and 22, also was an alumni of IIT Kharagpur, and he is the professor and head of the Department of Electrical Engineering there. And Amitabh ji is also an alumni of IIT Kharagpur. He studied mechanical engineering there, and he has done his management education at IIM Calcutta. He has many years of automotive work experience before he set up Time 2 Technologies. We see that there, right? Yeah, Time 2 Technologies. It's an engineering services company. And recently he also co-founded this company called Bionic Yantra, which helps disabled or specially abled people to have a better quality of life through devices that support the locomotor functions in the body. You know, if there is any impairment in the movement of legs or limbs, then the kind of devices that they develop will help in easy movement for these people. One of the unique things about Type 2 technologies is that they are in a very, very niche technology space. They designed landing gears for UAVs, and I just heard from Amitabh ji this morning that they've also developed the landing gear for a reusable space vehicle. Okay, something that goes into the space normally doesn't come back. It either keeps going in the orbit all the time, or it just gets destroyed as it enters gravity again. But something that is reusable means it should be brought down to earth and land safely and be used again. So they've developed the landing gear for a reusable space vehicle. So I think these are the kind of things that make us feel very proud of being an Indian, right? The first time that an Indian company has done these landing gears for military aircraft. Landing gears for civilian aircraft, I think, are less stressful compared to the landing gears of military aircraft which land with a very high speed. And then the landing gear for a reusable space vehicle is something that I couldn't even imagine, right? And then they've also developed seating for aircraft. We'll be surprised to know that in India there is no company that makes seats for aircraft. Type is the first company that has developed, and now they are trying to manufacture these products for supply to airlines. Because in the aircraft industry, the aircraft manufacturer doesn't install the seats. It is the airlines who buy the aircraft and then who install the seats. So the seats have to be sold to the airlines. That's what they are doing. So I thank Amitabh ji for accepting our invitation. I spoke to him about 3 weeks ago. Asked him to come here as a jury, and he accepted it immediately. It's an honor to have you here with us today, Amitabh ji. And I hope you will find the time today worthwhile. Okay. So with that, I will conclude my remarks. I wish all the best to the participants in the conference, and my best wishes to all of you. Okay. Now the first presenter is Siddharth. Yeah, over to you. Come.
So, good morning one and all. My name is Siddharth, and I belong to the electric drivetrain team of HBL. And so I want everyone to closely check this picture here. So what I see here is actually the future of HBL. So my presentation will be like, it's something which moves forward, like its future aspects. So here what you see is just, you can see that there are a lot of commercial vehicles. We are into e-mobility, commercial vehicle business, and you can see that there is buses, heavy commercial vehicles, light commercial vehicles, small commercial vehicles. So you have a lot of business aspects here. So what I am trying to pitch forward is actually a business idea. So you generate more revenue when you have a better portfolio. So how do you generate a better portfolio? So you generate better portfolio when you have a lot of products. So I am trying to pitch here something or a new product idea which will actually sell in market. So it's one of my honest approach, and I am trying to bring out a product here and also a technological solution to counter the same. So from all this, I am actually focusing on one thing here, which is the e-bus. So why I have selected e-bus, which will be told in the upcoming slides, and I would like to coin the term here, born electric. So this is the motto that I am keeping for the e-bus that I am proposing here. So hence presenting you my Vipassana 2023 topic, HBL e-bus, the way forward. So these are my contents. Why electromobility? So approach to electrification of buses. Then e-bus approach, born electric. So retrofit challenges for buses. So what is the upcoming market potential that I have? Then developmental concepts and why HBL should invest in e-bus, and what is the technological solution that I am proposing. So why electromobility? This is a common concept that everyone knows actually. So the main driver for electromobility is actually the energy efficiency. So for the same available energy, you can actually travel more distance when you have an electric vehicle when compared to a diesel vehicle. Because if you look at the efficiencies of an IC engine, it's normally around 40 to 50%. Whereas if you consider an electric motor or something, you have pretty much high efficiency, like around more than 90%. So the main key player here is actually the energy efficiency. So hence you have a lot of available energy, hence you can travel a lot of more distances. But there are certain technical limitations that we have, which is the range. All those aspects we have to think about. But if you just focus on just the term available energy, it is pretty much more for electric vehicles. Then approach to electrification of buses. So I would like to relate this to a sofa. If you see it here, I would like to coin two terms: born electric as well as reborn electric. So if you have a new a sofa here and you remove the legs and replace it with new legs and then you send it into market, it's kind of, I can term it as reborn electric. As well as if you are making a product from the scratch, then you can term it as born electric. In the retro business, we are actually modifying the base portion of it, just adding a EDT kit, and then we are selling it. But if there are certain advantages and disadvantages, which I am trying to come up. So why retro will be bad for electrification of buses? That's the aspect that I am trying to come up. So product build quality. If you look for a born electric bus, we know the components that we are making. So we will have a better high build quality as well as product flexibility. But if you are just adding a EDT kit to a existing vehicle, we have to suit the sizes based on our the available space. So the advantages that we have is very limited. Then modularity. We know our component size, like I said. So, but we'll have to size it down based on the available space that we have. Then NVH issues. So if you look at reborn electric, we can only improve the NVH issue of EDT kit, but we can't improve as of such a full vehicle. Because if you look at electrification of buses, unlike trucks, which we generally do, we do have a kind of emotional connect to buses, unlike trucks. So I feel electrification of buses might not work that for retro. If you look at durability, it will be for a born electric bus, it will be very high. If you look at overall portfolio and reliability, maintainability, but since we are making it from the scratch, the cost aspect we have to think about, which is a little bit high. Then e-bus approach, born electric. So these are the main aspects which I would like to talk today. So what are the retrofit challenges for buses? Then what is the market potential? Then modularity, flexibility and sustainability. These are the key aspects which I would like to talk about today. So retrofit challenges for buses. So I want you to focus just column wise. And you can see that for buses, unlike trucks, there are various configurations. If you see it here, there is a front entry door, middle entry, rear entry. Then if you look at, there are double decker bus, single decker bus. Then if you look at the chassis concepts, monocoque chassis is there, radar chassis is there. So in like for buses, there are, unlike trucks, for trucks the configuration is exactly the same. You have a front engine and your configuration is exactly the same. But for, if you look just at the vehicle architecture, you have a lot of configurations coming up. Then if you look at vehicle dynamics point of view, you have understeer and oversteer concepts. So if you have a engine kept in the front, then you have understeer happening. Then you are having an engine kept at the rear side, then you have oversteer happening. Then there are rollover concepts. Because when you take out a single bolt from the vehicle, you have to be very careful because it will affect the vehicle dynamics of the vehicle. Then you have durability aspects. Like I told, you can only change, when you do retrofit, you can only change the bottom part, like the EDT kit of it. But since we have an emotional connect, you can't improve the perceivable durability of the components. Then you have rattling. You can only improve the NVH aspects of the EDT kit as a whole. But you can never improve as a full vehicle, you can never improve.
That what is NVH?
Noise vibration horses. Then you have another vehicle architecture, like you have rear engine concepts, front engine concepts, like which I earlier told. Then if you have to be very confident even if you remove a single component from it. Like for retrofit, what we do is we adjust the component somewhere based on the available space. But for bus it will be more crucial because you have rollover concepts, understeer, oversteer, everything will happen. Then you are again like drilling the chassis or like drilling the chassis to adjust, like the vehicle which comes to retrofit is more or less like 15 years old or something. So when you retrofit it again, what happens is the possible durability of the vehicle again comes down. Like moreover, all these factors we can adjust somehow, but if you look just at the market of this, there are a lot of players which are available in the market right now. You just look at Tata, you have 100 models of buses. So retrofitting a bus, I think, which will be a problematic case. Now let's look at the market potential. So if you are coming with a e-bus right now, these are the source of market potential that I have seen. So you have central government allowances. Like there is a policy called FAME, which is called Faster Adoption and Manufacturing of Electric Vehicles, by which you will get incentives. Like for each kilowatt hour you put in the vehicle, you get around 20,000 rupees. Then if you are manufacturing your own motor, then you will get another set of incentives. If you are manufacturing your own vehicle in-house, then you will get another set of incentives. So this is actually because the government is trying to remove all of the IC engine buses and they are trying to adopt electric vehicles into the market. And apart from all this, the central government policies, you also have state government policies. So if you check at Maharashtra state, you pretty much have again a lot of incentives. If you look at Telangana itself, you have road tax exemption. So each state has its own EV policy which adds to the incentive, like it adds to the revenue. Also there are many private players. You can see Zimbus, Purple, Green Cell Mobility, Chalo. So all these people, what they do is they are unable to make the e-bus, so they will buy it from outside. So recently from Switch Mobility, Chalo had bought around 600 e-buses. So this is when you make an e-bus, it's actually generating a lot of revenue. Apart from this, if you just look at the e-bus sales in India, it's exponentially increasing over the years. Then you have a lot of players, not lot, but you can say unlike trucks. You have main players as Tata, Electra, PMI, Photon, Switch Mobility, JBM Group. So basically there are 7.5 meter, 9 meter, 12 meter and 13 meter buses available in the market, out of which the most selling ones are 9 meter and 12 meter bus, out of which 9 meter is having more business. So if you just look at the business portfolio, Electra and Photon PMI is having more or less the biggest market. So unlike the companies that we have heard of like Ashok Leyland, Tata, but these companies are pretty much new to us, like Electra, BYD, Photon PMI. So if they can do something, so I think we should also be able to do. Then sustainability. Like we have a high degree of localization. Like I think HBL is not realizing the power that we have in the market right now. So if you have just look at the market, you can see that you have a high degree of localization. Every components we are making in-house. And since we have the knowledge of it, if we assemble together, we can make a better product. So if you just look at this batteries, we are importing the cells and assembling it in-house. More or less other OEMs are importing it from outside together. Traction motor, no company in India is actually making it. Wiring harness and connector assembly, everything we are able to, like, we have a high degree of localization. Only thing that we lack here is actually transmission development and body and chassis development of a vehicle. So if we are able to make a product as a whole, since we already have EV surge strength. So if we combine this together, we will be able to make a better product that will actually sell in the market. So that's what my idea is, and that's what I am proposing. So flexibility. These are actually modern concepts into e-bus development. So this, like, what people do is, like, these concept is of Mercedes-Benz, this is of Volvo. So what they do is, you make it into certain modules. Like you have a rear module, front module. Based on the length of the bus that you need, you arrange modules. So we actually know what we are capable of, or the component sizes that we are able to manufacture. Just because we need to supply it outside and be an underdog, I think that's not needed, because we have the full capability to make it in-house, and we have the full capability to sell a product. So here we have mastered full knowledge, and we have the knowledge of everything. So we have the flexibility to make it like into modules, and we can construct it together to make a full product based on the wheel-based requirements. Then why HBL should invest in e-bus? So the agenda that we will be keeping in our mind is sustainable. We are sustainable. The products, we know that we are flexible because we are making everything in-house, and we have the chassis construction that I am proposing will be modular in nature. And these are some of the requirements that I am proposing. I know that this is bare minimum, but this is what I am proposing. We need regenerative braking. Our chassis will be most light, and which will help us to carry more weight. Then we will be adopting low rolling resistance tires, which will increase the range. Then we have intelligent HVAC system, and the motors that we are developing right now is modular in nature. Then flexible electronics, then the chassis dynamics, then cellular battery design that we have to, based on the available space, we have the full flexibility to modify. So regenerative braking minimum it should be 35%. We have the capability to make 30% weight reduction from competitors from the chassis dynamics. Then lower rolling resistance tires, which will improve the range by 10%. Then the concept that I am proposing will be adaptable, flexible, modular, as well as energy saving. So from the development efforts that I'm basically asking you just 4 to 5 months of time to make this dream product come alive. This is the schedule that I am proposing: concept detailing and portfolio establishments, which I have little bit completed. Then powertrain and vehicle aggregate sizing, detailed engineering and part development, vehicle build. So around in a 4 months time, I am proposing full vehicle, which will actually sell in the market. So this is the concept that I am proposing, first of its kind for HBL, which will be modular, flexible, as well as energy saving. So you have a front module, you have a rear module. So in the rear module, entire electronics will be kept, and front module will be fully flexible. You have left-hand drive as well as right-hand drive, so that you can sell it outside in the abroad market. And the entire battery will be kept in the mid module, and based on the wheelbase requirements that the customer asks, we will be adjusting it based on the requirements. So this is the modular concept of e-bus that I am proposing. Like I told, the battery will be kept in the mid module to adjust the weight and other balance requirements. So I would like to conclude by telling that without a sense of urgency, desire loses its value. Like HBL, like I told earlier, HBL has that we are making all products in-house, but HBL unfortunately is not recognizing its power, I feel. So we have the full flexibility to make a product in-house, and if other companies can do, I feel we also can make something in, like we are making in-house everything. So what other companies is selling it at like a 1 crore, we can sell it at a very less price. But everything demands some time. So without a sense of urgency, desire loses its value. So that's how I wish to conclude. Thank you.
Thank you, Mr. Siddharth, for that innovative presentation. And I invite questions from honorable guests and guest assessor, and also from audience as well.
Then, so how we can compete with the batteries with hydrogen technology?
What I see is actually it's not that developed yet. Hydrogen market, it's not that developed yet, because it will consume a lot of money as well as volume from the e-bus aspects that I have seen. So presently, the concept that I am proposing is a fully e-bus, like a battery electric vehicle.
Anyone else? So you started your presentation by talking about born and reborn, right? Retrofits and full OEM vehicles. Are there electric buses running in Hyderabad?
Yes, yes.
They are running in my city, in Bangalore as well. So I'm not sure if any of them are retrofits or are most of them.
I haven't seen any retrofits of e-bus.
They are born, right? Yeah, that's what I also thought. So where are these reborn buses running?
I've seen in abroad market a company which is doing retrofit for e-buses, but even we have also an experience retrofitting an e-bus, and it was not generating that much value.
Right. And secondly, in your business proposal, you seem to say that HBL makes most of the subsystems, and so you are proposing that HBL enter the business of making the complete bus.
Yes.
That's what I understood. And there are the other companies which are already making completely electric buses, but they seem to buy the subsystems. They don't make any of them. So does HBL supply the subsystems? Is that a business also possible? Supplying these subsystems to the other electric bus makers?
Yeah, yes, that's also possible. Because we had a recent customer named Tronchim, so we were actually supplying to them.
So since you're talking about a business model, did you evaluate that business model as compared to completely making a bus, or does it, what are the pros and cons?
Yeah,
Of being a key supplier of subsystems to other bus makers?
subsystems to other bus makers, like what I understand is actually when we developed subsystems for Tronchim, we had little bit of difficulty in adjusting to their requirements. So mostly when people do, they have a predefined chassis or based on which we will be assembling all components. So we had to suit or adjust or modify the components based on their requirement. So that might increase cost for us. Like right now we know all the component sizes that we have. So why not make something born electric for us? So that's what I'm saying.
Yeah, that's a very good answer, very insightful answer. Thank you, Manish. Good answer.
If you make it, you don't underprice it. You said that the competition is selling for 1 crore, and if we make, we can sell it at a very less price. Selling it at a very less price is not very enthusiastic. You know, we are not capturing value for all that we are creating, right? So we should try to maintain the price level, not lower it.
So, from what you have shown, so we are doing everything except body and chassis.
Yes.
Correct? Correct. So, we as a company, we say we are engineering is our business. We don't ever actually go into anything commercial. We do specialized engineering work, right? So, don't you think what we are doing is specialized engineering except body and chassis? And that's any other company is also doing that, right? And we as a business think that we do core engineering and then let others do the same. That's where we are partnered with Torsion, right? So don't you think that's the right model as such? I mean, I think Jury has hit it on the nail already.
Yes, sir. One thing is, when you bring out something, you have two aspects. One will generate revenue, and the other will generate a portfolio. So when you just supply it to Trontium, you are just an underdog. You like HBL will not get that name and fame. That's one thing. Other thing is, you have a better portfolio. Like other people will look forward to you. So that kind of power and possibility is there with HBL. That's what I'm telling.
Okay, it depends on the choice. If you say name and fame, okay, that's not what our business is. So, anyways, yeah, I understood your point. Yeah, I think HBL stands for specialized engineering. So that's where we want to be in that space, not as a commercial vehicles business as such. I think if I go back and remember, I think that's the reason why we are not into this automobile batteries business. We are only in specialized batteries business, right? Yeah. Thank you.
There is a concept called hybrid with the electric and also with the diesel engine or petrol. We have that concept too. So do you have any further idea on that?
Yeah, we can, like this is just a overall chassis or body concept that I'm trying to propose.
Yeah.
We can incorporate anything inside.
Yeah.
You can be a fully battery electric or like hybrid. Any concept can be proposed.
So if HBL makes complete component like HBL makes the bone electric bus, so if we get into the hybrid also, then it would be a value added for our country, I think.
Yeah,
True.
that's actually flexibility aspect. So
Yeah.
you can bring in anything.
Yeah. Okay. Thank you.
I request attendees here.
Hi Siddharth. Can you explain more about this modular chassis? Because the thing is that we are worried about drilling few holes on an existing chassis. But when you actually split the chassis into multiple parts, how will you retain its strength and those things? Like that thing.
Yeah. So I feel you can design anything when you know the loads.
So it's about like, and the next part is every modular, like based on the chassis, like every time it is kind of a new chassis development for every requirement. Is it?
No. We are fixing our front module and rear module. We will be only adjusting the big module.
Ultimately, like when you get approval for it.
Yeah.
So at that time you have to get approval for a chassis as a whole, not as a front module or what. So how will it be the timeline and all that? Like how difficult will that be considering a single chassis, like for a particular design?
I think this will be faster.
Okay, we'll discuss it.
Can I may add to it?
Yes, sir.
Hello. Yeah. Tirthankar, what generally happens is you have a portfolio and then you decide on a worst case criteria. So you only supply one vehicle, but when you want to get extensions, you can get extensions of 10 or 15 vehicles.
And they can be of a different design.
Yeah, they can go of a different design.
Design in the sense like you're choosing a model and
Yes,
so that can be extended.
that can be extended. Anyone else?
Yeah, anyone else? Yeah, thank you, Siddharth. That was an excellent presentation.
Before calling the second presenter of the day, I would like to introduce myself. My name is Tejaswini and I would like to continue this event as an MC. So let's call our second presenter of the day from TMS team, Train Management System. So without a delay, please join me to welcome Mr. K. Sridhar and Mrs. K. Srilata to present on their topic, Automated Table of Control Tool, which is designed to support the development of TCAS, EIS and TMS.
Good morning, one and all. I am Srilata, working as developer in TMS. Here I am with my colleague, Mr. Srilata. Today, our presentation topic is Automated Table of Control Tool. So, this is basically the reinnovated idea that came into existence because as we are facing the situation of inconvenience with the existing procedure. So these are the points that we are going to discuss in our upcoming slides. So what are the requirements and the existing procedure and the issues that we are facing with the existing procedure and the proposed tool that we came up with our automated tool and the advantages of being using the automated tool. So before going into the detailed explanation about the automated tool, let us have some key information regarding the project. So TCAS. It is a prestigious project taken up by the Indian government, which is led by Modi as a part of Mission Raftar. The main aim of Mission Raftar is to increase the speed of the trains, to increase the frequency of the trains and to avoid the train collisions. So TCAS is being renamed as Kavach by the Indian Railways. So it is being planned to implement in all the major routes initially and subsequently to all the routes across the India in order to avoid the train collisions. So the Indian Railways has been budgeted thousands of crores as a part of Kavach and HBL is looking forward a major chunk of portion under its revenue. So to implement multiple projects of TCAS, we need to get into the reinnovated ideas which reduces the engineering work that being done by now. So if we implement the project on time by thinking of the reinnovated ideas like automated tool, we can get the project complete before the time so that we can get any completion bonus. Otherwise, we need to pay 50 lakh fees. So, signaling interlocking plan. So, this is the approved layout that we are going to get from the Indian Railways, that we are going to design in the digitalized form. So, this signaling interlocking plan mainly contains the information of all the signaling elements such as tracks, points, RFIDs. All the information will be containing in the signaling interlocking plan. So, coming to the RFID, so this plays a key role in the project TCAS, which is containing the information of absolute location and the tag programming data. So, the main purpose of the RFID is to locate the position of the train in the station. So, and the table of control. So, the table of control will be containing the information of routes and movement authority. And along with the TCAS, this tool can also be used by the other projects such as train management system, centralized traffic control and the electronic interlocking system also. So,
Up to now we have seen the key information regarding the project. In the next slide we are talking about the requirements. So this is the approved SIP that we are going to receive from the railways, so which need to be designed in the digitalized form. So this, if you see this is the yard layout containing the information of RFIDs and its absolute location and all the signals, LC gates, all the information will be digitized in the form of yard layout. So this data will be done by the engineering people. So all this data will be designed taking the reference from the SIP. So all the information will be digitized taking reference from the SIP which we have received from the railways. So once this data is prepared, we need to get it approval from the railways. So table of control. So the table of control will be containing mainly the information of routes, from which signal to what will be the first signal and what will be the exit signal, and what will be the tracks included in the route, and what will be the RF tags available in the route, and what will be the movement authority from the exit signal. All the data will be containing in the table of control information such as the track profile, mainline profile, etc. Tag position data. So tag position data is mainly used by the site engineers at the locations, so which is used to position the RFIDs at their respective positions. So this document, this data will be containing that information, means what will be the absolute location of the RFID with respect to its signal. So all the data will be containing in this data. So next we are talking about RFID tag programming file. So for each RFID there will be data that need to be programmed into it to place in the at the site level. Okay. So this data mainly contains the information of what will be the previous tag and what will be the next tag and what will in which location it is located, means in which station it belongs to. All the data will be programmed in this document, and this data will be programmed into the RFID tag. So now up to now we have discussed about what are the requirements that is data that is being prepared by the engineering people. So now we are talking about what is the existing procedure that have been used. So if you see this is the RFID layout that has been drawn by using the AutoCAD, which is containing the information of all the signals, RFIDs and all the data. Means it is the digitized form by using the AutoCAD layout. So this is the TOC data which is prepared manually by the engineering people. So containing the information of all the entry signal, exit signal, in which line it belongs to, and what will be its aspect signals, and what are the tracks involved in the route, and what are the normal points, reverse points, all the data, RFID absolute distance, all the data will be containing in the TOC, which is done by manually. So next is the RFID tag programming file. This tag programming file also will be done through manual data entry only. So what will be the previous tag, next tag, all the data. So RFID tag position file. Again the RFID tag position data also will be done through manual entry only. So issues with the existing procedure. So drawing yard layout is a time-consuming activity. As you see, through AutoCAD, it is a time-consuming activity, and once yard designing is completed through AutoCAD, so next we have to prepare the tag programming file and related tag position data and TOC. All the data need to be generated manually. So as the data is being entering manually, so the possibility of man-made errors is more. So So, and the verification of, for the verifying the data that has been prepared by the, through manual basis is also need to be done. So, suppose if any corrections are need to be done in the early process, that is RFID design layout, so the respective changes need to be done again in the next outputs also, means such as RFID tag programming file, tag position data, and TOCs, all the data need to be corrected again in the next outputs also. So, to mitigate the issues with the existing procedure, we have come up with a solution with our automated tool as follows. Okay. So, we have the tool, we have designed our tool in such a way that there may be the representation, means the requirements may vary from one project to another project. So, for TCAS, the representation may vary, and for TMS and other TCAS also, EAS also, the representation of elements in the design layout may vary. So, we have designed our application in such a way that we can represent the elements based on the project. Suppose if you see in the layout, the signal, if you see the signal here, so the representation of the signal in the TCAS project is like this. So, if you take up the TMS project, the signal representation may vary. It is not same as like in the TCAS project. So, the signal representation may vary based on the project with our tool. So, TOC. So, once yard design, once RFID layout design is completed through the automated tool, whatever the TOCs which we generate, which we prepare manually, can be generated through our tool automatically. So, this is the sample layout which we generated automatically through our tool. So, the basic work what we do is, what to do is, we need to enter the basic information while designing the layout only. So, with that data, it takes the whatever the required data, it will generate into the TOC output form. So, station template. So, as we design RFID layout, with that layout, we can create a station template, which is as replica of the existing design. So, and we can use this station template to create another station with the same signature. So, in that way, we can reduce the designing time of the yard layout also. RFID tag programming file and tag position files. So, same as like TOC, which is generated automatically, the respective tag programming file and tag position files also can be generated automatically through our tool. So, and all the outputs which are TOC, RFID tag programming files and tag position data that can be generated through our tool can be taken in different formats like Word, Excel and PDF. There may be scenarios where we need to represent the elements outside the station area into the design layout. So, we are giving a feature that we can represent the outside station area elements also in a dotted pixel representation. If you consider this is dotted representation and this is the without dotted representation. We can consider these elements as in-station elements and this can consider as the outstation elements. This feature also can be available with the tool. So coming to the advantages of using automated tool, we can say that this is a unique tool for all the projects. So the same tool without any configuration, without any modification, we can use it for all the projects. So for TMS, TCAS and EAS, for all the projects, it can be the unique tool. So, and it is time efficient because once we design the RFID layout, all the respective outputs such as TOC, RFID tag programming data, RFID tag position data, all can be generated automatically. So, as all the outputs are generated automatically, there is a less possibility of man-made errors. So, and the verification also, so coming to the verification part, verification also need to be done on only RFID layout. So, if once RFID layout is verified and if any further connection is need to be done on the RFID layout, it has to be done on only RFID layout only. So for all the remaining updates will be updated automatically in the respective outputs. So there will be no need to rework on again on the generated outputs. So and also we have designed our tool in such a way that it is very user friendly and the design flow also is very smooth. So and there are also no license required as it is a company owned tool. So there will be further no license also not required. So as of now we have discussed about the advantages using automatic tool. Now we are going to discuss about the analysis between using our existing procedures and versus automated tool. Suppose if you consider a medium size yard layout. So for designing the yard layout, it may take suppose 14 hours. If it may take suppose 25 hours for designing a yard layout. So through our tool, we can design it in 12 hours also, 12 hours only. So on the TOCS also, it can be generated in a minimum time. So totally, if we consider, suppose for a medium size yard, if our efforts are nearly consider 75 hours, so through our tool, using our tool, we can get it work done by 25 hours. We can minimize the maximum time by using the tool. So this way we conclude that data in an efficient way, in an efficient manner.
Things like that. And it seems that your automation, you enter the data once. There is a algorithm or software that organizes it into different formats. So you take the control on the RFID position layout, and is there understanding there?
Yeah. Yes.
Okay, thank you. So the last part of your the last line in front was very interesting, that no licenses. So in general, for software, that represents a very important business model. So does this tool that you have developed has applications as a product in itself for other companies or other railway organizations and so on, do you think, or it is only something that we need internally in HBL?
We are not sure how competitors are doing, but this is the initiative actually we have taken, and the same thing we are using even on other projects also, like time management system and other projects which we are using same.
Others can use this tool, but we don't want to enable them. Then they do the projects faster than us.
I don't have any more questions at this point, okay? But thanks for listening.
I request audience to challenge the presenters on their excellent presentation. Okay. Yeah.
Suppose there are 100 tools and a combination to be prepared out of one layer. So how many combinations can be prepared using your automated tool?
All. If 100 is required, 100 can be made.
Right now this combination of multiple methods. combination of both existing, both entry and exit also is there now?
Yeah, we have green to green, green signal to green, green to yellow, all these combinations are available.
And one more challenging part we are facing is preparing is again SLM file from the layout. That is the time consuming which I request you to complete that one also.
Sorry, can you repeat?
So we are preparing a SLM file.
Okay.
Station layout file, station layout drawing. So that is one of the challenging job now. That is the type taking. So I request you to complete that part also.
Yeah, sure. Doing that.
Yes, definitely they'll do it as.
Yeah, small.
Yes.
Yeah, can you compare it with kind of a percentage? How much percentage of time is saved? That is a better idea.
Overall, you can say 1/3.
Yeah,
25 versus 75 is what we are, means these are the factors what you are taking with the existing, where what it add. We are not talking about the smaller add.
Can you show the slide once again?
Yeah.
That showed about 75 and 25.
So total if you look at, this is around 75 and this one is around 25. 25, may not be 25, maybe 26, 27. These are all we are talking in terms of hours. So because if you look at the these places, there is actually it is 0 here because the verification need not to be done for the remaining outputs which are being generated automatically. So only verification can be done only for layout. So this we are considering as more or less same time. So we don't have any advantage there. But only thing is, once we are doing this, so the verification for the remaining 2 activities will be 0. And rework also obviously will be 0 because we are only talking about layout only we are doing the modifications. So obviously rework also will be less.
Here, I do not agree with the layout design. Layout design will take more time compared to the CAD.
That is what actually we are talking as a reference. What even engineers what they are using right now, maybe they are not used to it. So these are the reference actually we have taken from our experience multiplied by 2. Suppose if you are considering in medium ad, I think now or something actually you are taken as a reference. So there actually if they are taking 3 days or I will say 27 hours. 27 hours, we are considering as we can do it in 5 hours. Since they are not used to that tool, so we are considering about 10-12 hours.
That's okay, sir. So, can you tell me what's the accuracy? So, have you guys looked at the accuracy of what's being done right now manually versus with the tool? So, is there any percentage comparison as such?
No, percentage comparison, we have not come to that level because we have not used it for the complete project as of now. It is under development process.
So, that would be an important factor.
Yeah, exactly.
Pradeep, again, that would be depending again how accurately they feed the data.
Yeah.
Error may not be there, only the inputs that is fed on.
That is the reason actually we are mentioning it as with the minimum errors we are saying. We are not talking about complete 0 errors. Because if the feeding itself is wrong.
Sir, one more question.
Yeah.
Anyhow, we are entering the manually. If the combination is being entered manually wrong, is it going to automatically detect this the wrong combination of signals?
Up to some extent, like example I will say there is a signal already used and you are giving some other signal with the same name. So it will give an error automatically, it will correct it. It will not correct, it will give a prompt.
Prompt, okay.
For some extent.
Okay.
One more thing, it is based, rather I would say application based, client server based, how many people at a time they can use this application together.
So as of now, means already we are running this application in Indian Railways where 150 nodes are already connected. So we can use 150 users at a time. It's a client based basis only. And database and all will be at a specific location. So we have what you call security features. If user is not assigned, if user IP is not assigned to that particular user, he cannot access that tool.
Sir, so using this tool, can we automate TOC completely?
Yeah, completely in the sense I am saying, we can say 90%. That's the reason actually we have given us some percentage here.
Like movement authorities, can we automate, sir?
Yeah, movement authority also can be automated. That is what actually we are doing right now.
That is the fundamental requirement.
Yeah, because signals and sections will be.
Yeah. So as of now, in initial version what we have given, actually we have given it as part of version 4.0 TOC. But now there is a requirement, actually we are going ahead with the 3.2. Whereas in 4.0 there is no movement authority in terms of meters and all. Only as part of 4.0, movement authority is given number of signals. Whereas in 3.2 it is mentioned as number of meters.
Okay, sir. If you automate a tractor fine TOC, which is in 4.0, then it will be very helpful.
4.0, this is one more proposal for SSP data to be added in TOC.
Sorry?
Speed profile also to be added in the TOC part.
Okay.
So that is the case, it will be.
I think we are running out of the time. I think I can.
Thank you, Mr. Sridhar. Thank you all for asking. Let us invite our third presenter who knows how to recharge batteries in cars and also in our brains as well, and who can enlighten us in the future of power electronics in transportation. Please welcome Mr. Ashok Bhupati to share his insights on compact onboard DC-DC converter.
Thank you very much. Yeah. Good morning, madam. This is Ashok Bhupati. I am a lead engineer in power electronics. So, first I would like to thank Siddharth. He already gave an introduction on EDT, like what are the components are there and all. So here I will go on. Like I will be presenting onboard DC to DC converter, which is one of the components. So as you see the picture. So this is our current product. So we are aiming for a like less dense product. So I will be just discussing how we can achieve that.
Less dense or more dense?
Yes, more dense. I am very sorry. Yeah. So this is my presentation outline. So first I will start with an introduction. Then I will talk about power density, why it is required. Then I will talk about converter topology, and then planar magnetic. So these three parts will cover the presentation. So this is the, let's say if you take any bus, truck or anything, so you'll have batteries and the other components, other power electronic components and all. So here I'll be focusing on, my first, I have two presentations today. So one is on DC to DC converter and another one is on motor controller. So first I'll start with the DC to DC converter, where I'll be focusing on how to make it as a more dense product. So what is the purpose of DC to DC converter? So you have an traction battery which is of a high voltage, and you have an auxiliary loads which are of low voltage. So we need to step down the voltage to power the auxiliary loads. So to do that, we should have an onboard DC to DC converter. So this is the converter topology, where you have a traction battery which is of 450 to 750 volts range, and you have auxiliary loads which are of 24 volt or 12 volts based on our application. So in between we should have a conversion, power conversion. So for that we will be using some switches, transformer and inductor and some sort of diodes. So initially we have DC. So in order to convert this DC to DC, first we will convert it to AC, then we will step down, and then we will convert it to DC again. So this is our current topology which we have used in our current product. So this is the 3D model of our first version, where you have a power converter, this power card, control card and the transformer, inductor and the capacitor section. So now we will see how we have to minimize them. So first I will start with the power density. So first we should know what is power density. So power density is the ratio of power delivered by the DC to DC converter to the volume of the DC to DC converter. So if you see the comparison with our current product with other players, so our first version is having a power density of 0.27, which has a power of 4 kilowatt, whereas E10 is having a power density of 0.496. So we are at half of that E10's power density. So my motive is to increase the power density, so like minimizing the volume and so that it can give the rated power whatever we are defined for. So how we can do that? So these are the objectives. So first one, as I told, first one is the power density. So if you are, let's say if you are reducing the converter size, so that we can accommodate more batteries. So batteries are the main power source where they can cover long driving range. So next one is converter topologies, where I will be discussing about few wide band gap semiconductor devices. So there I will be talking about converter topology. Third objective is magnetics. So currently we are using a conventional magnetics. So now I am proposing we can go for planar magnetics. So first, in order to reduce the product size, the first component is switching frequency. So if you are increasing the switching frequency, the product volume can be reduced drastically. So first one is, so you have in our product we have transformer and inductor which consumes more space. So as you see, this is the inductor L value, which is inversely proportional to the switching frequency. So if you are increasing the switching frequency, you can reduce the inductor value. So this is one. The next one is the transformer. So again, the transformer's core area product is inversely to the switching frequency. Again, we are reducing it here so that we can reduce the transformer size. The other things where we can focus on, as I told, if we are able to increase the switching frequency, we have some wide band gap semiconductors which we can go for. So SI we have already used many times. So then next is SiC. In our current design we have already used SiC and we have switched at 100 kHz. The next one is GaN, gallium nitride, which you might have heard recent days. And next one is diamond. Definitely we won't go for this now. So these are the advantages using this wide band gap semiconductors. So first one, they can operate at high switching frequency and they have a low on-state resistance, so that you will have less number of losses. Then you have an excellent reverse recovery characteristics. So I'm talking about, mainly I'm focusing on SiC and GaN, and SiC is having a higher thermal conductivity. So in our current product, we are using SiC, and in our future product, we will be going for GaN. So this is our existing converter topology, as I told. So here you have a input voltage which is a 450 to 750 volts, and you have a transformer which will step down the voltage, and then you have a rectifier section which will again convert it to DC. So if you are using an SiC device, this topology will support with SiC, where it can actually you are having a battery input voltage as 450 to 750 volts. So SiC can support up to 1200 volts. Whereas if you go for GaN, which is having a medium voltage levels, so which is max is 650 volts. But here our battery voltage is 450 to 750. So this topology won't be supporting for GaN. So we should have another topology. So which is like here you are having one switch. Sorry. Yeah, we are having a one switch that we are dividing. We are we are connecting two switches in series, so that the blocking voltage of 1200 will be shared among these two switches. So this is the proposed topology, which can be having a low profile and which is having a more base, so that it can be cooled easily. So in our current version 2, we are going for this planar transformer. So which, as you can see the size comparison, the planar transformer is of less size than the conventional transformer. So if you see what is a planar transformer, so in conventional transformer we are just winding it here, whereas in planar transformer we are having a PCB, onto that we will be having the windings. so which will make the transformer compact. So these are the advantages we will be getting. As I said, we are focusing on power density. So this planar transformer will make us our product more power dense. Then it will significantly reduce the height, so which is of low profile. Then we can, once we come up with our proof of concept on one product, then we can automate that production. Then it is having a greater surface area so that it can improve the heat dissipation capability. Then winding structure facilitate interleaving, so we can parallel the windings. Then it is having a less AC winding resistance and low leakage inductance. So I would like to conclude my presentation. So as I mentioned, the high switching frequency is the key for reducing the volume of power modules. Since we are switching at 100 kHz, the GaN semiconductor devices can be switched up to megahertz. So we can explore that option, and we will be doing that. So with the proposed idea, we can achieve high power dense onboard DC to DC converter, which will provide us a market edge. So this is the action plan I am proposing. So first version, we have already achieved a power density of 0.27, so we already proved our product. So to compete with E-term, so the second version where we will be using SiC with increasing the switching frequency, where we are targeting a power density of 0.6. And I would like to thank Ms. Renuka madam for doing this. And the third version, where we will be going for GaN devices. So here, since they can switch at very high frequency, so we are expecting that it can increase the power density up to 2 kilowatt per liter. So these are the target dates. So the version 2 we are planning to bring it on 7th month, and the version 3 on 10th. So I like to thank I would like to thank Kiran, who will be working on this third version.
You should thank him after.
Yeah, sorry. Yeah, so finally I would like to say HBL battery maximum and others minimum. So thank you for your attention. Any questions?
The reason for this DC to DC converter is that you need low voltage for certain applications in the bus.
Yes.
And you need a very high voltage for the traction application. Right?
Yes. So from traction battery, we will be drawing for the loads.
Right. So to get that low voltage, you are converting the DC high voltage to first AC, and then stepping it down the transformer and then rectifying it back to DC. Now, the source of your high voltage is from cells, which are themselves at very low voltages.
Yes, we are having a battery pack, so it will be up to from 450 to 750 volts.
Right. So looking one step before the battery pack at the cell level, the battery pack has some kind of series arrangement of cells to produce a high voltage. I am imagining it should be also possible to create a parallel.
The reason behind why in the converter topology we are using transformer, so it will provide an isolation from the loads. So that is one reason. So if you are connecting the loads directly to the battery, if something happens there, so it will affect the main power source. So whereas if you use this kind of power converter topologies, so which will provide an isolation, so which will protect the battery. So that is one reason I can say.
The reason to not use a parallel circuit from the cells with the low voltage is to create an isolation from the battery.
Yes, we are creating isolation.
The other question I had was you gave a comparison with the other DC-DC converters, E-Tron and a few others. One of the things I noticed is that the voltage ranges that others have and the voltage ranges that you have, they are significantly different, almost 2 times more. Right? The maximum voltage is 450 and others are also 400 and so on. So somebody else at 800 as well. So what is the significance of that, and does the voltage range affect the feature that you are looking at, that power density?
No sir, the voltage range will only affect the switch what we are selecting. So this whatever the input voltage we are having, so that will be affecting the switch. So switch is having a blocking voltage, so that is directly proportional to the input, whatever the input voltage is.
But that does not affect the density.
No sir.
density. And the technologies that you have described to get a higher density, like for example, the planar transformer and the different semiconductor materials, have you studied these other competitors to see if they are using something similar or they are using?
Yes, they are using SiC right now. So we are also using SiC. So now, like the inside parts, as we can't see, but they are trying to compete them with the selecting other components like transformer inductors by making them planar, so that the volume of the product will be reduced drastically.
So let me see if I got you right. They are using SiC, yes, and you are also using SiC, yes, but they are nevertheless achieving a higher density.
But in that specification, they won't mention with what frequency they are switching, so that that I couldn't compare actually.
You haven't compared.
Yeah. So no one is mentioning what frequency they are switching. So again, switching at high frequency is also having challenges, so that we are working on.
So my field of work is mainly mechanical engineering. This is relatively new for me, electrical and electronics. But in our industry, we do take a very keen interest in the competitors' products. We do things like benchmarking, tear downs, and so on and so forth. And usually, most companies have a very good idea what their competitors are doing, what kind of architectures they're using, what kind of components they're using, or I guess they would know what kind of switching frequencies they're using as well. Okay, I don't have any more questions. Thank you.
Thank you for your question.
Any questions from the audience?
What is the impact of the non-cost?
There's like in version 2, it will be more or less same. So the planar transformer is also coming almost with the same cost of whatever the transformer we have designed. So coming to GAN, again, for proof of concept, so initially it will cost us much because initially we have to purchase the samples of GAN. Then when we are going for production, there it will the cost will be coming similar or less same with the whatever the current mock cost we are at.
We should make it in-house, not buy it from outside.
Oh sir, yeah, my next presentation will be on that, so that I will need to show.
Next presentation today or next year?
Today.
Hi.
Yeah.
You mentioned that the traction batteries, right?
Yes.
Traction batteries and voltage. So this is the same DC-DC concept can be utilized in the other applications like solar.
Yeah.
Similar.
Yes, yes.
Like solar also.
These power electronic topologies can be used anywhere. Like this topology is just meant for reducing the step down in the voltage.
Okay.
So these can be used anywhere.
Thank you.
When compared to transformers,
yes,
the transformers regular transformers will be a rating. Current will be lower than current capability will be lower than the planar transformer.
No sir, yeah, whatever I am comparing the transformers, both are of same rating. So if you are going for current, like that is what in planar transformer we will be paralleling the these windings. So we like the planar transformer also having the same rating of the conventional transformer whatever we are designing. So it will carry the current. Like. Yes.
How would you thermally manage?
Yes.
What would be the difference between thermal management of the current versus the current flow?
So, current versus?
The proposed flow.
Yes.
Because you're making it more dense, right?
Yes, sir. Yeah, that's a good question. So coming to GAN devices and SiC, they are thermally very good, sir. Like when you compare with motor controller and DC to DC converter, so motor controller should have a very good thermal management than the DC to DC converter. So here we are trying to achieve an efficiency of 94, 95. So this won't affect much on thermal. So when we go for motor controller, there we should have a proper thermal design. Yeah. So here we will out of 4 are able to reduce the volume of the component, then it will be very helpful for the integration team to do that. So that is one.
So you mean to say the space constraints
Space constraint, yes.
on the vehicle, space constraint?
Yeah. So that is one major challenge we have. Correct.
Okay. So we would benefit out of that.
Yeah.
Out of this.
What type of code? Current time of transformer, what type of code?
Core. It is an E-core.
E-core. The both are selling E-core.
No, here the area of the product will be lesser than the conventional one. So actually when you open the design chart, so there they will be specifying for conventional design one kind of course, and planar transformer they have separate part numbers. So that we will be choosing from that based on the power level as well as the area product what we are calculating. Yeah, any other questions?
Anyone?
Thank you everyone. Let us take a short break. Please have some refreshments. After having refreshments, let us come back. and a superhero.
So those who answered, they will be getting dairy milk.
What is the major difference between a T-Cast and a superhero?
Superhero is imaginary, T-Cast is real.
Any answers like that? Any answers?
Superhero is always there to save the people, so Tikas is also always there to save them.
Excellent. That was the answer we were expecting for. Okay. Yeah.
Tikas is like avoid the collisions. Then Superman also will do that by avoiding the collisions.
Thank you very much. So one more question. Why do you think the maths book is sad? The mathematics book is sad. Why do you think?
That's a very easy question. So
One more question. Why was the computer felt cold at the office?
it makes other people too hot. No, we are expecting some other
Some funny answers.
Is it? No, not is it. Not at all. Any other answer? Go on.
Because of COVID.
Pandemic situation is
Think about software and
Yeah, software side.
Yeah, because you are using Windows.
Yes. Ubuntu is the correct answer.
So let us continue this presentation session. So let's call our fourth presenter of the day. They are our financial gurus who can make our worries due. Please welcome Mr. JVS Murthy and Mr. Devendra from F&A department, and who knows how to make our balance happy. So they are presenting on the topic named Budget Control and Processes for Arresting Revenue Leakages.
First time that a finance team is making a presentation.
That too not on collection on revenue, sir. That too not on collections on revenue. Sales generally, I think it should be on revenue.
Revenue leakages.
Leakages.
Yeah, good morning everybody. I'll try to make a presentation interactive. Let me try myself. So, see, basically what we observed in made me to make this presentation is we are having good revenues. That's a happy thing to know. But the sad part is we are also having some leakages, because of which we are not, what should I call, enjoying the 100% benefits of that revenue. So we observe that there are some leakages. Means, see, it's like when you are catching, filling the drum, and if the drum is having some holes at the bottom or side, definitely one will feel bad about it. How, and we will definitely try to arrest those arrest those leakages and what we will see that leakages. So in account, from the accounts point of view also, we also observed some leakages like that, and we put in place some processes so that we can arrest those leakages and we get the 100% benefit of our revenues what we are earning. Now there are two parts in it. One is customer related and vendor related. So I will go through those details in next slide. So customer wise is yeah. these are some of the leakages which we are experiencing in our business. Well, first part is LD, that is late delivery charges. So late delivery charges, definitely accounts is not having much role in late delivery. It is the production and sales team or whatever you call, all the total technical team which has to take care about this. But rebilling, definitely billing before work completion, non-collection of receivables, these are areas where we can put our efforts and ensure some definitely these are arrested. So why rebilling is coming is we experienced in this IPS and because of the pandemic, some bills were not passed in the time, and because of pandemic they did not work. And after pandemic they started working and they are asking for the new bills in the current date. So because of which what happened, we lost GST. So and so because we are losing GST, we thought by how we can arrest this. And the second part, billing before work completion. And now before billing completion means we are started verifying the PO terms of the customer and ensuring that we have met all those conditions which are given by in the purchase order by the customer. And then once we get a confirmation or we have a confidence that we will receive the amount immediately after the bill is submitted, or as per the PO terms we are confident that we will get the amount received realized, then only we are permitting for the raising the invoice to the customer. So this is the check which we are currently put in place, so that we will not have doubt on the realization of the invoice. So, and second part is we will not lose GST, because if customer asks for a re-invoicing at a later date, we will be losing GST, that situation should not arise. So these two things are kept in mind, and we have put the check in place, so that we will get the bills realized in time and we will not lose any revenue. The non-collection of receivables is, we are continuously, monthly we are having a review of receivables collections, and the CFO is participating in this receivables, so that sales and marketing team is continuously pursued on the pending receivables, so that we don't have bad debts. See, bad debts is definitely is not an allowable expenditure, and we have to pay tax on that also. So this is also a leakage which we want to arrest by pursuing the sales and marketing team on the by putting pressure on them to have collections in time, and there are no bad debts which will take place in the future. Then vendor related, coming to vendor related, we are having advances. We have to pay advances to the vendors, because the main part is what we observed is ours is an R&D product, and the items are mostly one-time order, or we have to go for a sample basis, as the production is not a continuous production. We cannot assure the vendor also about the continuous orders to them. So definitely most of the vendors will not allow for the credit period initially. So we have to pay advance. So but the problem is, when we pay the advance, some surprises is that vendor will make billing short to the some part of the amount will be the invoice is raised short to the extent, but not meeting to the advance amount. So that advance amount, some part of the advance amount is kept pending, and if no follow-up is made, that is not refunded. And most of the vendors may ask, you give the second order, then we will adjust it. But this is the problem which we will be facing, where the advance may not be get recovered and we have to write off over a period of time. Then non-filing of GST returns by the vendors. See, the new rule is that until the vendor files their GST return, we will not get the input on the vendor invoice what we have paid to them. So this is also a loss to us if the vendor doesn't file their GST returns. In such case, presently what we are following is, we have put in place is that we will not pay the GST amount along with advance. Only after supply and only after supply we will pay the GST amount. Sometimes vendors may not accept even for the holding the GST amount on the advance. Then we are asking for the approval from the business head, so that there will be a commitment on the purchase deal that they have to collect the GST. They have to ensure that GST is filed by the vendor. So that which way we are safe that the GST is filed by the vendor and we will get the input of GST credit. The short billing also, we have to pursue with the vendors whenever there is a short billing and get back those refunds. Happy to mention that we have pursued 4 or 5 vendors and got refund of 4.5 lakhs from the vendors. These are some of them are government and semi-government vendors. So these are the main leakages which we are observing, and we have put in place of the continuous monitoring of the vendor advances as well as non-GST filings. And the non-GST filing cases, initially before 6 months it was approximately 25 lakhs worth of amount which was not filed by the vendors. It was the highest in the HBL group. Out of electronics group was the highest in HBL among other groups. But today we have recovered approximately 15 lakhs of GST amount from various vendors. Even though they do not belong to electronics group, we pursued other group accountants to recover those GST amounts from their payable amounts. And also we have debited 50 lakhs we have recovered, and now we are at a stage of 4 to 5 lakhs outstanding, which are pertaining to latest supplies. So that's how we have reduced our liability to most of the extent. Then we come to this budget control. There is a rule or whatever I can say. There is a standard in accounting where the contracts are executable in more than 1 year. There is a process for recognizing the revenue. Compared to the compared to the estimate, the process there is that we have to estimate the cost which will be incurring for the execution of the contract, and comparing the billing and the completion of work, we have to arrive at a figure of what should be the revenue which need to be recognized in the books of accounts. This comes into effect wherever we have execution period of covering more than 1 year. So especially our TICAS projects, which are executable definitely not 1 year, which are beyond 1 year, like the contract itself says 24 months of period of completion. So in that aspect, this accounting standard will come into picture. Further, the first part is that we have to estimate the total expenditure which will be incurred. Then after that, we have to monitor this expenditure very meticulously, and when we have to arrive at the year end, we have to arrive at the total expenditure incurred against the estimate. Then what is the percentage of expenditure incurred against the estimate, but vis-a-vis the actual billing done. So when we go, see, this is the steps which we are doing. Revenue to be recognized is advertisement. Total estimated cost, then actual cost incurred, then percentage of actual over estimated cost. Then compared to sale value, revenue to be recognized will be the percentage of actual over estimated, the percentage into the total sales value. If the total actual sales amount is more than the actual cost estimate, percentage of cost estimated, then we have to reduce that sale revenue from the books of accounts already which is there. But if the sale value is less than the proportion to the cost incurred, then we have to increase that sale to the extent of shortfall. So this is the exercise we have to do at the year end for all these ICAS projects, for which what we have designed is we have estimated the cost for breaking the cost into various aspects as work breakdown structures, like factory made items, then site supply items, installations, travel, employee cost, third party contracts, then consortium partner costs. In these various aspects we have divided those costs and estimated the cost of against each of these elements. Against each of these elements we have started the capturing the cost against these elements. Then then this formula is applied for arriving at the how much revenue we have to recognize at the year end. See, for the why this is required is the auditors are asking, even to the extent of station-wise costs of manpower incurred also they are asking to the extent of details. Definitely which is not possible to arrive at the manpower cost in, overall we can say that manpower cost is this much, but definitely station-wise, work-wise we cannot give that minute details. So there is a way to overcome those pictures, but definitely we should have a control on the total against each element, what is the cost incurred to the extent possible, going into the minute details of the works being executed. So that we can address the accounting rule which has to be adhered to as per statutory requirements. So this is the we have earmarked one person, Mr. Nagendra, for this whole exercise by single point contact to do this exercise, because we have three projects in hand valuing 600 crores. It's not a simple task to controlling keeping the control on these costs, and we have to continuously pursue with interact with the project teams from site persons to project team and everybody, so that we can capture the costs accurately and against each element, so that which is definitely required for explaining the auditors and accounting part. So that's what I told you, that what's segregated into below categories. These are which I already explained to you. Okay, WBS element for identification. Then capturing actual expenditure, starting from Indian tracing, WBS element mandatory. Then SAP also helped us a lot on this exercise for capturing the expenditure based on the WBS. And every month we are taking a report and comparing ourselves, and we are reviewing this also. Auditors have also accepted this process for revenue recognition. This is the best part of it. So this is which we want to submit before you. Any questions?
Thank you very much. Any questions from the audience?
Thank you very much. This is a very interesting presentation, and I think I also want to appreciate your initiative in presenting something which people will not really think of as innovation or think of as technology or engineering. in a forum like this, but this is very important for businesses, no doubt about it. And I think the most important thing to do is to make engineers aware that the commercial aspects and the financial aspects also matter a lot. So thank you for highlighting that. If I understood your presentation rightly, the key thing is some of the aspects you normally would anyway do. I think you verify the GST claims or verify the invoicing and so on. But you brought the process of the system to those activities.
Okay.
And you also mentioned, I didn't get into the presentation, but in your summary you mentioned that there is a WBS work breakdown structure on those activities.
Yeah.
And that makes it, I think, easier for people not to miss out certain elements because everything is defined what the steps. That is the key idea.
Yeah, definitely. Thank you.
Nobody is right.
Question from questioning funds.
Sir, is there any alert if we observe any leakages in advance? Is there any possibility to identify those leakages in advance to alert the people to control those things in future?
See, first thing is we have to, whenever we are taking any, when we want to take any action, we have to check ourselves beforehand whether we are meeting the requirements or not. That is the only way one can arrest those leakages. If they do, see, at accounts part, when it comes to raising the bill, invoice or making the payment, definitely we will check that we have put in a place of system that we have to check for these kind of what you call compliances. Compliances are meeting the requirements, so that then only payments will get released or invoice is getting generated. So this is a preemptive check which we have put in place so that we don't have surprises afterwards.
So I understand that you have some checks and balances in place. What is that you are expecting from the rest of the organization to aid you, to help you get through this?
They have to go through the terms before they come to accounts for any requisition.
Can you put it in simple words so that everyone can understand?
Check the PO terms of the customer before coming for bill raising, asking for invoice, that they met all the requirements whatever stipulated by the customer. And they should ensure that once we submit the invoice, we will definitely get the bill, but there will not be any objections from the customer side that that payment will be held up. That control, that assurance they should have first before coming to accounts for invoices.
Actually, there are two aspects in this presentation that got, I think, probably mixed up. The first aspect was talking about revenue leakages, and the second aspect was talking about revenue recognition. These are two different components. So let us not focus too much on the revenue leakage part. If we focus on the revenue recognition part, if in normal product sale, you get a purchase order, you produce it, you deliver to the customer, you raise an invoice, and then you get paid. All this happens in a short period of time, and this is straightforward business. But in these TCAS contracts, these are EPCs, engineering, procurement, construction. And each of these projects is for a period of 2 years. And it is not a straight invoice that you supply to the, that you give to the customer, that is recognized by the auditors in the balance sheet as a sale that is made. So the sales are recognized on the basis of expenditure that is incurred, not on the basis of invoices that we are giving to the customer. This is a complicated process. This Ind AS 115 that you were talking about is a complicated process. Unless we have a very, very structured information to support what is the expenditure that we incurred and what is the progress that we made on the site, because it is not verifiable. The progress on the site is claimed by us only that we made the progress, because the supplier, if the customer accepts and receives the invoice, then it's very easy to say that I made a sale and the customer is willing to pay. Now I am actually claiming that I made this progress for which I spent this much money, based on which I am asking the auditor to recognize that I earned so much revenue. This is the difficult part, and what they have come up with, the structure of capturing costs and demonstrating the progress on the field against those captured costs. That is the innovation, and that is done under SAP. So it's a very transparent system of capturing costs and demonstrating what progress, which the auditors have accepted as the basis on which they can do revenue recognition. In the previous projects, it was taking a very, very long time and a lot of debate. But with this system that is implemented in SAP, the revenue recognition can be done very quickly and with no questions from you. I hope I clarified. Thank you, sir.
Any other questions?
Thank you very much. Let us call our fifth presenter, who is the power ranger of the roads and who can also make our cars zoom. Let us take a ride to the future with Ms. Shravani and her teammates from EDT department. Their topic is on fault tolerant control of dual three-phase PMSM. All the best.
Good morning everyone, I am Shavni, currently working as a hardware design engineer in EDT, and my team members are Bhupati sir and Krishnamurthy sir. My topic of presentation is on fault tolerant control of dual three-phase PMSM. PMSM stands for permanent magnet synchronous motor. So during the presentation, I will go through introduction, why PMSM is popular for electric vehicles, and what are the open phase faults that occur in PMSM, and what is the objectives that I propose in this presentation, and what is the fault tolerant control strategy. Then I will conclude the presentation. So, transportation has become a fundamental requirement in modern life. Almost every house has at least one vehicle in their house. The traditional combustion engines are being replaced with electric vehicles due to their advantages. An electric vehicle consists of parts like electric motor, inverter circuit, and onboard charger, and battery pack, and all other parts. So, as my presentation is on electric motors, I will focus on motors. An electric motor is a most important component in the electric vehicle. The chosen electric motor should have high starting torque, fast acceleration, and it should produce low noise, and most importantly it should have high efficiency. Currently these multi-phase motors are being used in the electric vehicle applications, and among them dual three-phase motors are more popular. A dual three-phase motor consists of two sets of three-phase windings which are specially shifted by 30 degrees with isolated neutral points. So, and when it comes to motor types, synchronous and asynchronous motors are being used in the electric vehicle applications. In case of synchronous motors, permanent magnet synchronous motors are more popular. Generally, a permanent magnet synchronous motor consists of a stator with magnetic fields produced by the stator and rotor. The motor is made to rotate at synchronous speed, and this is how the permanent magnet synchronous motor works. And this is chosen for most of the applications because the first thing is the rotor does not have windings, so it will have minimal copper losses, and also due to the presence of permanent magnets, it will have higher power density and good speed regulation. These permanent magnets are mounted on the surface of the rotor, it will have equal quadrature and direct axis inductance irrespective of the rotor position, and the electromagnetic torque that is being produced by the motor is only due to the magnetic flux. In case of and mounting of these magnets on the rotor surface is quite easy compared to the interior permanent magnet synchronous motor, which consists of these magnets has to be mounted on the interior part of the rotor. So this needs complex machinery, and surface mount PMSM is easy to construct. Currently we are using surface mount PMSM motors in our electric vehicle applications with axial flux type. So during this presentation I will talk about dual 3-phase surface mount PMSM motor. Generally fault is an abnormal condition in the machine, and these open phase faults are classified into short circuit faults and open circuit faults. These open phase faults are mainly caused because of internal stator winding failure and failure of two switches in the inverter circuit, and also the mechanical failure of machine terminal connector. So these faults will cause effects like they will create imbalance among the phase currents in the motor, and also they will generate torque ripples in the motor, and these will cause mechanical vibrations to the motor. So in the long run this is not desirable in any motor for reliable operation. So this has to be suppressed, or it has to be mitigated, and very quickly. So as you can see in the diagram, this is the torque characteristics. During the normal functioning, the torque is constant. When any open phase fault occurred in the machine, then we can see the torque ripples. The torque is getting oscillations. So this will cause mechanical vibrations to the motor, and this is not desirable. So in order to avoid this, we need to have a control strategy. In order to achieve the fault tolerant control of the motor, the simplest method is directly to remove the faulty winding set from the motor. For example, in case of dual 3-phase PMS, we can remove the faulty winding set and we can degrade it into a 3-phase motor for smoothening the torque. But this will reduce the torque generation, and this is not desirable. So, and also another theoretical method involves optimization of the currents to minimize the copper losses in the machine. That is also mainly focuses on the minimization of copper losses, but it will ignore the torque output capability of the machine. Therefore, we need a control strategy which will ensure that which will minimize the copper losses and also improve the torque capability of the machine. So by keeping these objectives, our control strategy is designed based on these objectives. So the main objectives are abnormal conditions like faults. So which is when written in terms of the copper losses, we can see that this copper losses is inversely proportional to the torque output capability of the machine. So from this relation, if we can able to reduce this copper losses, then we can able to increase the torque output capability of the machine. So this is mainly used as an objective in this control strategy. So this is the entire control framework of dual 3-phase PMSM drive. This is the 6-phase dual 3-phase PMSM motor, which consists of 6-phase windings, and the speed of this motor is sensed through encoder, and through speed calculator the speed is calculated, and by using some reference speed the error is fed to a PI controller which will generate Q-axis component of the current. Meanwhile, the 6-phase currents are being tracked and they are converted into 3 sets of orthogonal quantities using vector space decomposition matrix, and by using Clark transformation, these are being fed to a deadbeat control through a current prediction block, and by using some reference currents, the reference voltages are generated using this deadbeat control regulator, and finally these reference voltages and also the error between these two components is given to a PI controller, which will generate reference voltages, which are then again converted into alpha beta components using inverse path transformation, and these reference voltages are being converted into a 6-phase quantities using inverse vector space decomposition matrix, and these reference voltages are modulated using space vector modulation, and they are being given to an inverter circuit, which will generate driving voltages for driving each phase of the stator winding. So this is how the entire control framework of dual 3-phase PMSM drive would normally work. So during the faulty conditions, these reference currents are optimized, and based on this, it will generate. This will generate the these currents are optimized, and it will make sure that the actual currents would follow these reference currents, and based on this, it will generate the reference voltages, and then it is made, the maximum torque can be extracted from the motor during the abnormal conditions. So these reference currents are being generated by using, these are selected by using an algorithm called PSO algorithm. PSO stands for particle swarm optimization. So these are the mathematical expressions used to calculate the single phase copper machine, and also the maximum copper losses among all the 6 phases. So in order to optimize the reference currents, we need to have a much lower difference among all the single phase copper losses. For that, we need an objective function. This is an objective function. Using this PSO algorithm, it will use this objective function as a key component, and based on this objective function, it will optimize the current references, and it will output the current references. This is a block diagram of proposed maximum torque fault tolerant control. From this, it has sequence of steps. First of all, we need to derive the expression of maximum torque output. Then we need to establish an objective function for the optimization. Then we need to apply a PSO algorithm. This PSO algorithm will consist of, these are the constant, omega maximum and omega minimum, inertial constant, and Tn, C1, C2, these are all the constant. Xv are the position and speed of the iteration. First of all, we need to calculate the objective function using this equation, and then we need to update the P best and G best values. P best and G best values are the local best and global best values in the PSO algorithm. Then, if the calculated objective function is less than the preset objective function, or if it reaches maximum number of iterations, then this algorithm will output the current references. Or else, if this condition is not satisfied, then it will update the particle position and speed. Then the iteration continues. So these optimized current references are used here. So that is how the reference voltages will generate during the abnormal conditions. This control strategy is applicable for any machine with, in case of normal and abnormal conditions. So during the whole derivation of this control strategy, we can see that the machine parameters are not involved in this derivation. So we can say that this control strategy is applicable for any surface mounted PMSM with different working conditions, and also by using this algorithm, we can achieve a torque output capability of 73.3% of the rated torque, and these current references are suitable for any surface mount PMSM with the different working conditions. And in the similar way, we can apply this strategy for both single phase and two-phase open phase faults. I suggest this control strategy to be implemented traction systems, so that in case of any fault, in order to not to have simply shutdown of the vehicle, this kind of backup will helps to run the vehicle with for some time. So thank you all.
Thank you, Ms. Ramani. Now we welcome questions from our chief guest.
Shabni, I'm looking at this 73.3. That is, it looks to me that it is just 5 by 6 of the job, right? So one phase out of 6 is disabled, and the remaining 5. So that's more or less obvious, right? What is the extra thing?
So, we may not achieve this, like this algorithm will make us to achieve this, whatever the max. So out of 6, if one is gone, then with 5 phases we can achieve this 17.
Because the rest of the electronics may not really achieve this, so you are making it.
Yeah, like we should have an algorithm where it will maximize the torque to that level.
Okay, and there was something in the first slide which talked about the ripples.
Yes, sir.
So you are also able to control that ripple and it provides a uniform torque. Is that the case?
It may not provide exactly the same how it works in the normal condition. So actually we haven't simulated it, so we are expecting it will reduce the amplitude of the like whatever the amplitude we had in the fault condition. It will reduce the whatever the peak to peak what we have there.
Okay, thank you.
We welcome questions from audience.
How will you detect there is a fault? How to know there is a fault and how will you repair it later?
How will you detect that?
How will you detect there is a fault in the system?
Okay, like when the fault occurs, the current magnitude, which will be like hues. So with that we can detect the fault, whether it has occurred or not. So in the normal operating condition, we will have a current limit.
So you have a current sensor?
Yes, a current sensor. With that we will detect that.
And this is logged and given as a message or something? What? The fault. Yes, it will be logged and there will be some messages relayed?
Yes,
to some people there.
Yes.
Sorry to follow up with the question, but it's a 3-phase motor with a redundant second set of 3 phases. Is that right?
It's a dual 3 phases. Like.
Yeah, the dual 3 phase refers to a redundant phase. Is that right? The second 3 phase is a redundant.
We have like 2 stators between a rotor. So first stator will have a 3 phase, second stator will have a 3 phase.
Yeah, no, the question is it a dual redundant? It is not dual redundant. All 6 phases are and all 6 phases are needed to generate the
Any more questions? Okay, thank you very much, Ms. Shamli and Dr. Bhupathi. Let us have another round of question and answers, which are informative now. The general question which we ask every year, what is the task? The answer is already given. So what do we do?
We will not lose a huge amount if it is correct.
So in financial year 2022, it was 1,221 crores. This year we have increased to 1,352 crores.
Finance person is not supposed to answer.
Yeah,
So I should have informed earlier. Sorry for that.
Now I think we should ask sir to ask some question. So
ask him what will be the
What are the expectations for 2024?
that you ask.
1865 crores.
That is why he is having accurate information.
Some figure we have to tell us more than the present figure.
Okay, next question. Name the defense imaging firm in which HBL invested in financial year 2023.
The concerned person shouldn't answer.
The defense imaging firm in which HBL invested. Tombo. I think these are very easy questions. you should have prepared.
No, we should, with respect to divisions, should not answer these questions. The other divisions should answer these questions.
Okay, name the mission Raftar projects for HBL.
Now, EDT team should answer this question, not team.
Yes. Only EDT team members.
It's mission EDT projects.
Repeating the question, name the mission Raftar projects in HBL.
Western Railway.
Eastern Railway, Western Railway. That is
Sir, seems like there for there.
The projects are Eastern Railways, Western Railways and WCR, WR03 and WCR.
Yeah, next question.
End of the questions. Let's call our sixth presenter of the day, who is going to reduce our dependencies on fossil fuels, lower our carbon footprints and create more sustainable and greener world for our future. I invite Mr. Srinivas Valsa and Mr. Srinivas Baka from EDT department to present their topic on compact axial flux PMSM for EV applicants. Please welcome.
Good morning to everyone. My name is Srinivas Valsa. I am working in the EDT department as a manager, looking after all the electromagnetic designs of motors. And my superior, Srinivas Baka, who is in EDT R&D department. Today I would like to present a topic, compact axial flux PMSM for EV applications. Electric vehicles, known as EVs, which are operated on electricity, which can be stored, which stored electrical energy on the batteries of fuel cells rather than the fossil fuels. Next, the topics which I want to cover is what is axial flux motor, what are the configurations are available, what HBL existing motors are there, and in that how to compact the various options, and in that how the performance and what are the benefits of weights as well as axial lengths of the machine dimensions, and then conclusion. Axial flux PMSMs. Generally PMSM stands for permanent magnetic synchronous motor, which are being used in the electric vehicles. Here, axial flux motor is completely different than the radial flux conventional motors. Radial flux motors which are having the cylindrical in nature, whereas axial flux is the pancake type, like a disc type of motors will be there. So this is the example of one axial flux motor, rotor with PMs on both sides, and intermediately stator will be there. This is the one type of the structure. So the advantages are more torque for the given volume, compact and lighter, and high efficiency. Motor configurations. There are different types of configurations. Here I illustrated 3 types. One is single rotor, single stator structure, which is very simple, but because of the complexity in the axial force balancing, this cannot be done. And the next one is the double rotor, single stator structure. That means outside 2 rotors are there, and intermediately common stator will be there. So this will improve the efficiency as well as the power density. And here the challenges are the fixing of the stator to the frame or the housing, and the thermal management is very complex. And there is another configuration, single rotor double stator structure. Here the rotor is intermediately having both the sides of the permanent magnets, whereas the outside stators will be there, which are having coils. So dual rotor single stator structure, HBL is having already initial version, which is the coalesced stator structure, and single rotor dual stator structure, which is having HBL variant version, which is laminated stator core. And as of now, we are having the axial flux motors for the small ratings, and which are available in the market is very up to the like 80 kilowatt, like that only. But here we targeted for the bigger trucks like 35 ton truck, which can be useful for the retrofit of existing IC engine trucks of 35 ton and above. Here the output power rating, these are the continuous ratings up to 160 kilowatt, and the speed is 1500 rpm, corresponding torque will be the 1000 Newton meter approximately. These are the motor structures. Here the constraints are the outer diameter, active material weight, and axial lengths are these things. These are the things right now we are taking as a benchmarking. Then how to optimize this further? Actually, axial flux motors are already optimized in a dimensional point of view, but still there are some challenges in the different applications. Like we need to arrange the motors in a very small size, very small in a stringent places. So in the conditions, we need to design a motor in the very compact string size. And this is the stator having the coils, which is yoke, having the slots as well as the yoke in nature. And this is the rotor, which are having both the permanent magnets in the both sides. And this is the arrangement of the dual stator single rotor condition. These are the what we are having the different types of components in the axial flux motors are stator, rotor, and magnets, and then coils. So in that, how to where the options are, we need to verify them. So first we can take as a rotor core. This can be directly eliminated, but the thing is that we cannot maintain the high power magnets cannot be accommodated, and we cannot maintain the same air gap in the motor. So this is the structural issue. And the next is that magnet thickness. Magnet thickness, axial point of view, we need to maintain the some desired magnet thickness. But if you compromise and if you can reduce the magnet thickness, there will be high currents flown to the motor. That means performance will be deteriorated. And the next is the coils. This is also same phenomena which cannot be touched. And the stator too, under the slot field we need to maintain to accommodate the copper. If we cannot maintain, the performance will go down. And we are having only another option is called the stator, which is having core material and stator yoke type. That is the ESR. Stator core material is a laminated silicon steel core or soft magnetic composite materials. Presently we are using this laminated silicon core, which is a made up of silicon steel. And whereas we can propose SMC material, that means soft magnetic composite, it's a powdered material which can be compressed under high pressure so that it can be made as a solid. And the next option is stator yoke. We can also eliminate the stator, but it requires the dual rotor single stator structure. That means the intermediately stator will be there. We need to see the structural support and the thermal management in this structure. So we have taken these two options as a to make the compact axial flux machine. The next is stator material, which is regular one is this laminated CRNGO material, cold rolled non-grain steel roll. So which can be made as a lamination, it will be a roll and it can be punched as per our designs. And whereas SMC powder material, which is a particle, it's a mixture of iron powder and resin. This can be compressed and make as a solid block, and it can be molded easily with by means of dies. And here electrical resistivity is this much 0.52, which can the electrical resistivity, that means the core losses can be moderately, it will be there, whereas here higher resistivity, these core losses will be somewhat lesser than this. Next is it's a comparison of material characteristics. This is the conventional one. This graph is extrapolated by the software, but it can be only up to the 2.2 Tesla. And whereas this SMC thermal material, one of the grade we have taken as a 700 HR, 800 MPa, which can allow up to 2.5 Tesla with the range. And core losses point of view, up to 1.5 Tesla, core losses are more in the case of SMC, whereas compared to conventional material. But we are operating at lower speed only, because the truck requires very less speed, up to we are considering 1500 RPM only. That means approximately 200 frequency, edge frequency. But in the higher frequency applications, this SMC is much more better in terms of core losses. And SMC is having some limitations of these are the mechanical strength will be less, because this is a powdered in nature and we are compressing with the high pressure, making as a solid bed. But it cannot be as strong as the solid one, like conventional lamination materials. And this cost of the material is very high, and then limited availability. It is unlike regular silicon steels. We need to prepare this in a different processes. This is the limited availability. Next. This is the existing one, axial flux PMSM. This is the existing structure where the stators are both are outside and the intermediate rotor having the permanent magnets both sides. So this is the lamination stator core with the yoke. This laminated stator we need to prepare as a spiral type. So it's very difficult in the process. But lamination purchase point of view, material point of view, it is less, but process cost is much higher. And here, this is the proposing this topic, axial flux PMSM with the SMC core, which will be the intermediate with the stator will be there, and the coils are arranged in similar way as this one. So we are not changing anything, but here there is no yoke. Yoke means this portion, coil and this back arranged body is called yoke. So here there won't be any yoke on it. So we need to put the yokeless structure. So here all other active materials are remains kept the same. Only we analyzed these different types of stator yokeless. And here thermal management point of view, we need to maintain on this over the surface of the coils only. We cannot maintain side by side. This is the challenges. And performance in the simulations point of view, we got this is the existing one as a benchmarking we have taken this one to get the 1500 RPM, 1000 Newton meter. We got the 160 kilowatt approximately by consuming the 144 amps. In the same 144 amps, how the SMC core is generating, that we analyzed, and we got the similar way approximately the same torque, and by corresponding the losses. AC losses, AC plus DC copper losses are somewhat less than this one, and magnet losses are increased because of the saturation levels. So efficiency finally it has improved up to 0.5. Under this and these are simulations run at 200 degree winding temperature and 100 degrees magnet temperature. Here, because in the EVs, bigger trunks, we cannot maintain the temperatures up to 1 reason. So here we need to use the C-class type of material. And the next is open slot. As of now, we have seen this one as a present one as the open slot, which is a laminated one, which is having yoke. And SMC will not have the yoke, and only this cross type only will be there. And these can be supported by the mechanical features of non-magnetic materials. And what here from open slot to semi-closed slot, that means some projections will come and combined it together, it will be joined as an intermediate stator. This is can be done after the winding only. So this will be the exploded view for the visualization. Here this is the stator of one side and this is the stator of second side. After combining these two coils, we can rivet it together to make a single stator. And these are the rotor one both sides, and these are the rotors outer sides, and these are the coils intermediately and magnets which are attached to the each rotor. And by using this semi-closed slot, this type slot here, this sliper slot, we can maintain the same copper slot fill factor, because this side only we can insert the coils in the opposite direction, and the advantage will be the magnet losses and copper losses can be minimized. This is the performance summary with respect to the benchmarking and the open slot condition, and this is the semi-closed slot condition. Here in the semi-slot conditions, because of the saturations of the magnetic flux at the nearer to the tooth, so we will have the reduction in the current to get the same torque. Here try to maintain the nearer to that one in the simulation. So at 137 amps we got 137 of phase current, we got the same performance, but the little bit increase in the torque we put because of the saturation levels, whereas here core losses will be somewhat increased with respect to the open slot versus this one saturation, and magnet losses can be reduced with from almost 25%, and hence the efficiency has increased from 95.56 to 94.76 by using the SMC material with the semi-closed slot. Here the reduction in the magnet losses because of the AD losses can be minimized because of the saturation, and AC plus DC losses, that means skin and proximity losses of the copper losses can be minimized drastically. Whereas here from here to here around 2 kilowatts difference is there, AD current losses of copper losses, whereas here only 600 watts of the difference is there. That is the reason we could able to achieve the 1% of a higher efficiency compared to the benchmark. And that was the performance. Come to the weight comparison point of view, existing is the 69.4 kHz. This is for the active weights, whereas where we have reduced the yoke, removed the yoke, and we could get 12 kg, and the rest of the parameters are remain same, we didn't touch, and subsequently we got the 18% less than the laminated core structure weight. And come to the axial length point of view, compactness point of view, here from the stator point of view we modified, and the rest are the same. So from 76 to 52 we arrived. That means percentage point of view we can calculate 80% approximately with the axial length also. And the structural point of view, there are challenges, and also water management, cooling, thermal management point of view also some of the challenges are there. So these are the approach, means these we are not simulated structurally, but just for the idea purpose we can have some small rib of stator support structure, and then water flow will be this slot where the unwindings can be cooled, and this connection will be the potting material, will be the contact, so that effective cooling will be done for the thermal management point of view, where HBL losses or copper losses can be eliminated and transferred towards the housing. And also the structural point of view, we need to maintain this type of ribs by removing some of the material in the stator tooth. And finally, conclusions are, by using the SMCs, we can reduce the size and as well as this one, but even the higher initial cost for the molding point of view, to creating the new type of any complicated moldings, we can do this one by using the SMC material. And here weight and axial lengths are approximately 18% we can be reduced by the benchmarking in the existing one. And these are the efficiencies also, it has increased. That means the range can be increased by 1%. So here Euclid structure, we need to take a special attention on structural and dermal design. This is the thing. Here.
Thank you so much, Mr. Students. Now we welcome questions from our chief guest.
Very nice presentation on innovations in the motor. How long did this take? How long was this? There were about 2 or 3 different things that you did. What was the time period over which you achieved all those steps?
Stresses we analyze.
No, this project was how long? These different iterations? About 2.5 years. And you gave some numbers about the efficiencies and so on. So the differences are small, right? 0.5% and so on. So how do you actually measure that? How do you calculate this?
Efficiency point of view, it's first one is 93.5, second one 92.7. Change is 1.2. If you see the total losses point of view, AC losses, big trouble for the high power rating machines is heat dissipation. If we are producing more losses, even the 1% change in the efficiency can result in a significant change in the total losses. If you see the first case, the AC plus DC copper losses resulting 7.9 kilowatt. In the last case, it's a 5.9. There is a reduction in the total losses, and especially the copper losses by 2 kilowatt. That means an added advantage while we are maintaining the thermal. The thermal management point of view, it's a great advantage for high power machines.
Okay, thank you for pointing that out. So what you are saying is that although you highlighted that efficiency increase, that does not seem very significant in terms of a percentage gain, but because of the reduction of losses, that is a very large, both as a percentage and also the practical consequences of that. Because so much heat loss you have to manage, right? So much heat removal. Okay, thank you.
The other advantage is that this is an additive process. The conventional process is a reductive process. So from a material sustainability point of view, the SMC is because it's an additive process.
There won't be any scrap on it, like conventional steel.
So out of this, in SMC, out of open slot and semi-closed, which one you say superior? Either open or semi-closed? Because in efficiency wise, the semi is better. But when you go for the current and torque ripple mainly, like their torque ripple is 3.8% than 1 point. Like how we will, what is like we should focus on torque ripple or efficiency. Let's say if I am making a control algorithm, I will look at torque ripple. So which one?
In general, for EV applications, anything less than 5% of torque ripple.
Okay.
Yeah, this is okay. So it's a change in 1 point something to 3%. It's not a significant difference. From the torque ripple point of view, both the numbers are.
Okay, thank you.
It's like choosing the right girl to marry. Many things that you have to consider, and so you need to optimize, maximize everything.
You're gonna try.
Huh?
You're gonna try.
He can try, you cannot.
Yeah, any other questions?
Any questions from the audience?
So, what's the cost to benefit you will have using the laminated stator versus the design?
Sir, it is the production point of view. For example, if you go for the laminated core.
Currently, we are already using laminated.
Yes, sir. Per kg, we are getting around 300 rupees. Cost per kg of lamination. But for a single stator, single stator is consuming around 20 kg of laminated core. But when we are producing the stator, to cut the required profile, we are going to be medium wide cutting. It is expensive process. It is costing up to a lakh per stator. So the cost point of view, raw material cost point of view, it's significantly low if you compare with the laminated in SMC. SMC is 3 times more. Cost point of view 3 times more compared with the laminated. But the raw material point. But the process point of view, laminated is very expensive to manufacture the stator of our required dimensions. But SMC is a molded structure. the complicated data structure can be easily printed. I mean, easily made to complicated more. And the process point of view, it is a less expensive, very low expensive compared with the other.
As far as data price is concerned, so you are saying 1:3.
Yes.
Parameter point of view, process point of view, it will be none of it. And the magnets used are same in
Everything is less than
there is a magnet.
Yeah, magnets are there.
Okay, any other questions?
That is actually the drive. The weight reduction and the volume reduction are the drivers. Even if, let's say, we spend the same amount of money with laminated foam or SMC foam, we are able to reduce the weight and volume. The customer is willing to take.
Any more questions?
I have a question on the rationale of going for the axial flux motor. Is it used in the hub? Is it or is it on the chassis? Yeah, because yeah, because hub motors is one trend in at least in smaller vehicles. I don't know about trucks.
It can be used in both.
Yeah, any more questions?
Thank you very much. Ladies and gentlemen, our next presentation topic is on common gate driver card using silicon carbide MOSFETs over IGBTs for different high power rated motors. Move on from the Iron Man. We have got a new tech superhero, Mr. Lokireddy Kiran Kumar. He says that why settle for IGBTs when you have a superior silicon carbide MOSFETs? All the best, Mr. Kiran Kumar.
Good afternoon, everyone. My name is Kiran Kumar. My idea is using common gate driver circuit using silicon carbide MOSFETs than IGBTs for high power rated motors. For high power rated motors, we need inverter for converting DC to AC. High power motors, rated motors having phase voltage and phase current in terms of 100 volts and 100 ampere. So switch has to withstand high voltage and high current. Generally, these are my contents. First we will see why IGBT is required. Why general IGBT is preferred than silicon MOSFET. Because IGBT has very less conduction losses than silicon MOSFET. That's why IGBTs are preferred for high power rated motors. But after introduction of silicon carbide MOSFET, it has some advantages than silicon MOSFET. Most of the it is like similar to IGBT in some things. So we can use silicon carbide MOSFET like IGBT. Then later we will see what is gate driver. Why gate driver is required for switch. Then later we will concentrate on silicon carbide MOSFET timing characteristics. Then later we will calculate gate driver circuit components, resistor calculations, what is the range of resistors required for gate driver if you use silicon carbide MOSFET for inverter application. Later we will compare both silicon carbide MOSFET and IGBT power dissipations. Then we will compare timer management between silicon carbide MOSFET and IGBT. What are the advantages will come if you use silicon carbide MOSFET.
You don't have to make any calculations, right?
No, sir. Already calculations are done here, sir. Here it is given already. IGBT can withstand high voltages, so IGBT is preferred for high power motor. But after introduction of silicon carbide MOSFET, it is having very 10 times more critical breakdown voltage than silicon MOSFET. So for same voltage withstanding capability, that the size of the silicon carbide MOSFET will be almost 2 times less than the silicon MOSFET. And also it is having 2 times more thermal conductivity than silicon MOSFET, and it is also having 14 times less conduction losses than silicon MOSFET. So silicon carbide MOSFET can also be used instead of IGBT in motor power, high power motors. This is a typical off bridge of inverter where 2 switches are used. If you see the bottom switch, this MOSFET is having parasitic capacitance. This gate to source and gate to drain, these two are parasitic capacitance. If you add gate to source and gate to drain capacitance, we call it as input capacitance of MOSFET. Generally, we have to supply here positive gate voltage, so that we have to give some charge to this input capacitance, so that in order to turn this switch on. In other way, we have to give negative voltage, so that we have to take some charge out of this capacitance in order to turn this switch off. So in order to turn this switch on and off, we have to control the charge by choosing this resistance. This is the typical timing characteristics of MOSFET. If you see here, first of all, MOSFET is in off state, so gate voltage is negative. Once we apply gate voltage positive, it starts conducting, means switch is getting turning on. So once it completely turned on, this entire load current will flow to the switch, and voltage across the switch will come to 0. Same way, when the switch is turning off, the voltage across the switch will increase to DC voltage, and the current across the switch will come to 0. This is the typical gate driver circuit, and this is the switch. In order to turn this switch on, we need to supply positive gate voltage. Here, this positive gate voltage will be given by this DC converter, and once the PWM comes here, once the PWM is high, this inside gate driver IC, this P MOSFET will be on, so that if you see this red line, this 15 volts will pass through this resistor, this RG1 resistor. This RG1 resistor will control the charge. It will control the turn on time of the switch. In the same way, in order to turn off the switch, once the PWM is off, this N channel MOSFET inside a gate driver IC will be on. If you see this blue line, negative voltage will come across the gate of the switch. It will take the charge from the parasitic capacitance, so that switch will be turned off. These are the important characteristics of the silicon carbide MOSFETs. In the data sheet of silicon carbide MOSFETs, they will be given what will be the turn on delay time and rise time, turn off delay time and fall time. Turn on delay time plus rise time will be the total turn on time, and turn off delay time plus fall time will be the total turn off time. And they will be given how much charge has to be given to the input capacitance of MOSFET, so that the switch should be on. These are the actually for different high power rated motors, based on the phase current requirement, we have to select the switch. Suppose if the phase current is 200 amperes, we can select 105 ampere continuous rated switch. If the motor requires more current, so according to that we have to select the switch. These are the timing characteristics of the switch. Suppose that if the load current is 100 ampere, this is the turn on time. Means below this time, once the switch is manufactured, the turn on times will be fixed. Means below this time we can't turn on the switch. That we have to take care. See, these are the typical 4 different silicon carbide MOSFETs of different current ratings. From the data sheet, I have written here how much charge is required to make it turn on and turn off. Charge is given here. Generally, in our company, for our motors, that fundamental frequency of phase voltages is in order of hundreds, means 100 to 500 Hz frequency. So, in order to achieve that frequency, switching frequency has to be more than 10 times at least. So, if you take switching frequency 20 kHz, time period is this 50,000 nanoseconds. Generally, turn on and turn off time will be the percentage of time period of switching frequency. If you take turn off time and turn on time like 2% and 1.5%, here in order to achieve this turn on and turn off time, we know the charge and we know the time. Current into time is equal to charge. So from the time and from the charge, we calculated the this current requirement. These are the current requirements of the switches, corresponding switches, to make it turning off and turning on. These are the typical operating gate voltages of the silicon carbide MOSFET. Silicon carbide MOSFET's advantage is even the switch current rating is increasing, that operating gate voltages are almost same, 15 plus 15 to minus 4 volt. And gate charge requirement also will be nearer to each other. We know the voltages and we know the current. From that we can calculate the resistors, RG and resistors and RG of resistors. These are the range of turn off resistor values and turning on resistors values of different switches. Suppose if you want to use same turning on resistor and turning off resistor for all the switches, what will happen? See in next slide. I am using this same resistor 4.76 ohms to turn off the switches for all the switches. If I use the same resistor and we know the charge requirement we know, and we know the current, we know from that we will get the time. From this you can see this column. If you use the same resistor 4.76 ohms, that turn off time for these corresponding switches are here: 136 nanoseconds, 294 nanoseconds, 466 nanoseconds, and 750 nanoseconds. Then you can see here. From the table, you can find that turn off time is 136 per 105 ampere switch. Turn off time is 294 nanoseconds per 300 ampere switch. So if I go back, see, you can see here our turn off time is more than, if you see here 100 ampere, it is around 80 nanoseconds. We got 136 nanoseconds. It is more than the given time in the data sheet. So it is possible. Okay. So from this we can say that using the same resistors, turning on resistor and turn off resistor, can be used for all the gate driver switches of all the means we can use you can use same components for all the switches. And here also DSAT protection is nothing but suppose if any fault occurs in the inverter, that high current will flow through the switch. So we have to observe what is the voltage across the switch if any high current flows. Here in this data sheet, it was given what is the maximum allowable current through these switches. We have every switch will have some channel resistance across the drain to source. If any high current flows to the switch, that voltage across the switch will be equal to channel resistance into current flowing through the switch. So that drain to source voltage of all switches I have calculated here. they are all nearby. So we can take this 2.55 voltage as we can consider this voltage. Means we can here. If any high current flows here the drain to source voltage will be around, if you take 2.55 volts for all the switches, here there will be some DC protection circuit in the gate driver IC. Once the PWM comes here, once the switch is turned on, this inside gate driver IC, this switch will be off. There will be internal current source will be flowing through this circuit. Means the voltage across the switch plus this diode voltage drops, and this current source into damping resistor. If you sum up all these voltages, if it is more than the threshold voltage which was already there in the IC datasheet, then this pulses coming from the IC will be off. Like that way we can protect the switch if there are any high currents flow through the switches in fault conditions. So after that, in previous presentation, Valsara sir has told about this motor. I have calculated the power loss calculations for that motor only. Suppose if I use IGBT, that power loss across IGBT switch is around 966 watts. If I use silicon carbide, it is around 261 watts. It is almost power dissipation from the switch is almost 4 times less. This is any thermal network. Thermal network is nothing but we have to dissipate the power so that we can maintain the junction temperature of the switch to 125 degrees Celsius. If the junction temperature of the switch goes beyond 125 or 150, then switch will damage. In order to maintain the junction temperature of the switch around 125 degrees Celsius, we have to dissipate the heat, power dissipation from the switch. This is the thermal resistance of the switch. And in order to maintain 125 degrees Celsius, the case temperature of silicon carbide MOSFET is 98 and case temperature of IGBT is 76. The ambient temperature is 30 degrees. If you take, then the thermal resistance of the cooling system. If you use silicon carbide, it is coming around 0.26. If you use IGBT, it is around 0.04. So almost thermal resistance of coolant, which is used for IGBT, it is almost 6 times. It should be almost 6 times less than the silicon carbide MOSFET. Thermal resistance is less means we need good cooling system, which is having more thermal conductivity. Thermal resistance is inversely proportional to thermal conductivity. If thermal resistance is very less, we need more thermal conductivity material to transfer that heat. But you can see here, using silicon carbide MOSFET, the thermal resistance of the coolant is more. So we require very less area of heat sink or with less pins can be used if you use silicon carbide. But if you use IGBT, the thermal resistance of coolant, it should be very less. So good thermal management should be required if you use IGBT. From this we can conclude that with same components we can have a common gate driver card for all the switches. And second thing is silicon carbide MOSFET thermal, due to its less power losses, very less thermal, we can have more thermal resistance of the cooling system. So not much thermal management is required if you use silicon carbide MOSFET. So safety point of view, it is very good, and also efficiency also it increases more because thermal loss power dissipation is reduced almost 4 times. And one more thing, the size of the switch also reduced by half. The height of the silicon carbide MOSFET is almost 2 times less than the IGBT. So our controller, motor controller, inverter, that size of the motor controller also will become compact, and thermal management also is easy, and power density also will increases, and safety also will increase. Thank you.
Thank you very much, Kiran Kumar. Now, questions from Chief Guest.
What I have heard in general is that the IGBTs are the most commonly used technology for these kind of switching applications, and especially high power, right, in railway locomotives and so on and so forth. So, outside of your work, are you aware of other places where silicon carbide is replacing IGBT?
In the silicon carbide data sheet, they have mentioned it can also be used for motor applications.
Yeah, right now, but in practical uses, have you come across examples where this is being done?
Till now, I didn't aware.
You have not seen. So this would be perhaps one of the very rare or early examples where you are going from IGBT towards silicon carbide and finding a benefit from it.
Yes.
Silicon carbide came up in one of the earlier presentations also, right? In the SAC converter.
Yes.
I'm not from this.
For your question, nowadays most of the companies they are more interested on SAC. Generally people are nowadays they started purchasing the dies that I will be in the next presentation. So from that they are making their own power module, whatever. So actually now IGBTs are cheaper than silicon carbide. That is one main reason why we are going for IGBT. So now we are exploring SAC.
Thank you.
What's the criteria for increasing safety in this compared to the IGBT types?
Safety, sir. Safety means generally high power motors, they are in kilowatts, maybe 150 kilowatt or 200 kilowatt. That the phase current will be in hundreds. So there are more chances of failing of switches. Means if the power dissipation is thermal management is not good, there are more chances of failing.
So I would like to add the answer to it. So as he mentioned the comparison, so IGBT is having very less. Can you go to the table once? Yeah. So if you see there that at the last row, so IGBT is having 0.004, whereas SAC is having 0.29. So if you are using SAC, we can have a good thermal management than IGBT. So in our company right now, we are facing challenges on this thermal management. So if you are going for SAC, then we can have a better thermal management.
Question not on your presentation, but since so many of you are in the electrical domain, IGBTs are also used in the railway locomotives to convert the single phase current of the wire to, they have to have 3-phase traction motor. So that's one big use of IGBT. Is there any possibility of using silicon carbide there in those kind of applications? Those are really high power applications, high power and current. Are you aware of anybody?
There is no need to do that.
No need, is it?
There is no need to do that because there is a lot of space available, there is no weight restriction in a locomotive. And IGBTs are known to be very, very reliable devices. So there is no incentive for the locomotive traction power electronics to switch to silicon carbide. The incentive here is in electric vehicles. Electric vehicles and the automobiles. Now where space and weight are very important considerations. And the silicon carbide MOSFET can switch at a very higher speed compared to the IGBT. When the electronics is switching at high frequency, the capacitors and the coils tend to become smaller in size. And that's the reason why in the aerospace industry they use 400 Hz, whereas 50 Hz that we use on the ground. So the higher the frequency, the smaller is the size of the overlap electronic components. That's the reason why it is happening in the automobiles. In the locomotive, there is no incentive to do it.
But other places where compactness and
Exactly.
space, weight, all these are useful.
Yeah. These are expensive. These are expensive, and they are also quite sensitive to failure. So the purpose of this driver card is to turn it on and turn it off reliably, and also protect it from failures. Yeah, otherwise it will fail. So the purpose of this driver card is to protect us. In case any failure is going to happen, it should predict and then turn it off very quickly. That's it.
Thank you.
What is the purpose of EMI means?
Yeah, the question is like how you compare the EMI performance between IGBT and SIC?
So in this silicon carbide or IGBT, with respect to EMI, for both we have to consider EMI. EMI will be depends on not on that di by dt and dv by dt of silicon carbide. It is very less compared to IGBT. So due to di by dt and dv by dt of the states, that is only will be come as EMI to the.
So it will be more complex. For a silicon carbide MOSFET implementation, so the EMI will be more complex because of the high di by dt and high dv.
Yeah, Krishnamurthy sir wants to just add something.
It is EMI means it is depending upon rise time. It is fast rising. Fast rising means high day by dt. Okay, na? It generates more spikes, means ring during turn on time. It generates more EMI. Okay, it is depend not in SIC or IGBT, depending upon our turn on and turn off. Clear? Asad, clear? Turn on.
Any questions?
Okay, while Sam is thinking, so where do you plan to implement this? I mean, you did this expert and you did all this study, right?
We are working on
Which product do you
motors, motor controllers. Not only for electric vehicle, for any motor controller we need inverter.
Where other areas in electronic group do you see this area?
Other than motor.
Planning to use it anywhere else in any other applications other than motors? Are you planning to use this?
EV, sir, in EV chargers, it can be used. EV chargers, it can be used.
Anything on rail electronics?
High power master, any high power conversion can be used. High power supplies. It has been normally low power supplies, low voltage means this type of labor not required.
That's why I want starting high power.
Okay, can be used for any motor drives, not for EV, other motor drives, or solar drives, or energy storage systems, or EV chargers. This concept can be used. In energy storage systems means it is 100 kilowatts to 50 megawatts, not megawatt and 100 watt, 500 watt. This concept can be used.
Thank you, sir. Yeah, any other questions? Yeah, Tirthankar, any questions? No? Yeah, thank you, Giri.
all. We have completed half of the session with super innovative presentations. And let's pause these presentations for a while. Let's take a lunch break. We'll take this lunch break for 1 hour, that is from 1 to 2 o'clock. And after 2 o'clock, let us all join for poster presentations. Please have your lunch. Enjoy your lunch.
Yeah, after poster presentation, we'll be having game. So have a good lunch.
Yeah, post lunch it is very much innovative and entertainment as well.
installations and all. So they can showcase the photographs. So meanwhile, we can also have ample of time to focus on the innovations in the charger part. This can also be applicable wherever the case can be, other divisions. And we can note our leaks and lags, so that if any lags are there, we can improve that. So leaks means we can also enhance the different kind of features. Also, we can compare with the competitors and other technologies what are in the market, and then we can also focus the market, so that this can be a good productive solution for us.
So this deals with the chargers.
Yes, sir. Currently focusing on the chargers.
These are the chargers.
Yeah, these are the chargers.
This gives you all the information regarding the charger from the time the customer gives the specifications.
Yes.
Till the time you have delivered.
Delivered. And also afterwards, after installation, we can showcase our pictures.
Up to installation.
Up to installation. So meanwhile, we are doing.
Maintenance and all further up to after installation.
No, sir. No maintenance and all.
So
Only
till the time of installation.
Yes.
From the time the order comes to the time it is
installation,
delivered.
deliver and installation, and we can also generate automatic reports weekly, monthly, and also we can monitor from sales to the where what is happening in the ground level, production level, and other different stages.
So charges are different. Every order is somewhat different. What is the customized order? So therefore you have got slightly different requirements, slightly different
the process will reduce the time.
These are very important. These are productivity. This is also reduces errors because there are so many checkpoints.
In case of the engineers are changing as to their
Fresh engineers can also be learned from this.
They can learn from it.
Already we have the
So you already made this up?
No, it is a proposal stage.
Currently we are using another software for battery chargers. Single line diagrams, electrical diagrams, and the technical parameters are built out. We are already using this. This is the addition for complex part. We are using this need to be developed.
This is for the downstream also?
Yes.
For production. These are also for manufacturing.
Manufacturing business, we can monitor. We can monitor what's going.
So after this,
Yes, after coming down.
In general, these are the real recording use, right? Because repeated use, which will reduce the repetitions. And it will also be a use next time we do know what we done previously.
Yes. Also, we know over the period of time, we know how many projects we got and what is our success rate. Thank you. Thank you.
So we are going to make this software.
Yes, with the permission of our Vice President. Thank you, sir.
Thank you, Amitabh. Hope you had a great experience going through the poster presentations. I congratulate all the poster presenters. Showing so much of information in one poster is really a great task. I congratulate each and everyone. Let us give a big round of applause to all the posters.
So I request everyone to settle down. So now. is the schedule we had. So we are done with 7 presentations as of now. The 8th one was given in the morning session. So now we are left with PPT number 7, 9 and 10. So now the PPT number 7, RFID tag mounting bracket in DCAS project. So this is not a kind of presentation, it is a demo. So I hope everyone will enjoy it. So before going to the demo, since everyone had lunch, I hope most of them might be sleeping. So now we will have a topic time. So we have some few questions to ask. So I request the concerned person shouldn't answer those questions. Like last time someone has answered, so this time someone answer the question, they have to buy us one box of chocolates. Okay, so first question. So I hope everyone knows our company founder, okay, Dr. AJP. So I request the new engineers, so what is the full form of Dr. AJP? You remove the doctor, what is it? Alluri Jagadish Prasad. Anyone else? Wrong. That is no, wrong. No. So, yeah. Alluri you said right? No. Okay. Chocolates. Yeah.
Alluri Jagadish Prasad. Who said it?
Yeah. Now we will go for the second question. So I know everyone knows Vidyasagar sir. So his full name is MBB Vidyasagar. So what is MBB? Now again no new engineers only.
No direct reports.
No. Only the new entries. Yeah, MBB. What is the full form? Shall we give the chocolate or not? Yeah.
I ask a simple question. Who is the third presenter of the day? Very famous. One more question. What is the contract value for mission Raftar project of HBL?
It should be exact.
Exact scope. Very close.
Very close at the Sara chocolate.
Difficult question.
Okay, a little difficult question. So everybody were present here this morning and Vidyasagar sir presented his speech. He showed us 12 dimensions of innovation. Name at least 4. Yeah. No, we'll start with the engineers then we. Yeah. So what are the 4? Out of 12 at least we must say 4.
Good question. Operating.
No.
Tracking platform. Process.
Whoever is there, he can stand, he or she can stand and raise your hand. Yeah, I'm coming towards. Who is that? Yeah, can you please? You are really excited to answer that question, so please.
Value capture, offerings, platform, brand and processing.
Your peers are helping.
Anyone other than those 4? There are 12. Still have 3 more people.
Offering platform solutions.
Customer processes.
Customer experience.
Okay. What is the net depth of HBL?
Net depth.
Depth.
Zero. Net up. Zero.
And during the presentations, you might have heard there is a doorbell sound. What that is for?
First one.
Only
No,
have
one by
4
one.
minutes left. Conclude your presentation.
No, that's
15 minutes. Time limit of 15 minutes.
correct. Of course. Okay.
The most expected question.
Yeah, what is today's share price of HBL?
Today it seems the stock exchange is closed. What was the yesterday?
Is it BSc or NSc?
NSC 104.20.
So we give it to 104.2.
Yeah, one more question. This question must be answered by TCAS people. So currently, EDT is working on one project. So I just wanted to know the name of that project. So EDT people shouldn't answer this question, only TCAS. We are working very hard on that project, so it should be completed by June. So 35 done. Next.
The last one.
I think where else have made a big answer? Yeah, someone can finish the 35 ton bus, truck, car, bike. They are from EDT only.
Since the question is on EDT, I would like to ask another question. Why do you think an electrical engineer wears sunglasses to the conference?
To the
Conference.
lighting.
Sorry?
To avoid lighting.
To avoid?
Lighting.
Lightning. He doesn't want others to know who he is seeing.
Whatever the answer, it should be funny. We give it.
I gave funny answer.
Yes, sir.
Yeah, one more answer.
Yeah, 1 minute.
To hide his fear.
You
had already sleeping on now.
Why the electrical shock?
Fence is there.
Which sir?
Conference fence.
Then why he has to wear sunglasses? Non-cooling glasses.
Since there is a fence, so it's better to.
You should wear armor. You need not wear sunglasses. Anyone?
So it seems like you must read the answer what you know.
Because this future is so bright.
That I studied electricity.
Congratulations to all electrical engineers.
We hope everyone enjoyed this, so we'll move on to the presentation.
So let's move on to the demo. and who knows how to save our company's money. I request Mr. K.V. Rajshekar and Mr. Upendra from the purchasing department to present on RFID mounting bracket.
I'm just here to help my colleague Upendra, and actually it is his idea related to RFID installation, a bracket installation on the RFID tag, which would improve the speed and reliability of RFID tag fixing in TCAS project. So, of the many installation activities, fixing of RFID tag on sleepers is one of the important activities. And RFID tag is a vital component of the TCAS system. And in TCAS project, several RFID tags must be fixed on the sleeper to the railway track. On the railway tracks, on the sleepers, these RFID tags are fixed. Now, each tag is to be fixed at a designated location using mounting brackets. And the project, say for example, a typical 100 kilometers route, if we have to fix these tags, around 3,000 tags are to be fixed. Mostly this work is laborious and labor incentive work. And these people have to work in odd climates like hot summer, early morning, winter seasons. And the frequency of trains that are traveling in this machine is very high. These trains travel at high speed and the frequency is very high. Every 2 minutes, 1.5 minutes, 2 minutes, we find trains. So installation time is basically very less. So there is a tremendous pressure on these people to complete the installation, and being again a labor intensive kind of work, which is prone to errors. So in the recent installations or the past installations, we have many reports where there have been errors. To avoid that, Upendra has suggested one idea. We'll get into the details of it. Now we are talking about the current scenario, what it is. Basically, for an RFID tag, there are three major components. Yeah. Basically, the RFID tag has three components. One is the RFID tag itself, then the base plate, and the third is the mounting bracket. This assembly is dispatched from the factory. The mounting brackets and the tags are separately shipped from the factory for shipping convenience. If it is assembled and then shipped the package to or rather it will consume more volume. So they are shipped different packets, like the mounting bracket is shipped separately and the tag. Now at site, what these people do is they fix the tag, fix the mounting bracket to the base plate. So to fix that, you can see there are two nuts that are fixed here, 1, 2, 3, 4, to these two brackets. So at site, each tag should be fixed to its bracket using 4 bolts. There are 4 bolts, and the bolts should be tightened to a specific task. So that is also one of the important criteria to ensure that it's fitted properly. So these things take more time. The bracket set is inserted. This assembly is then inserted on the sleeper. They remove the ballast and then they fix to the sleeper. So the bracket set is again inserted on the sleeper, and the stud should be inserted at each bracket from one end to another end to fix the nuts. These are the nuts. So it is difficult when this on the sleeper, when the ballast is removed and the nuts are fixed, they use the spanner. It is very difficult to assemble. So with this existing design, it takes time, more time, and it is also, as I mentioned earlier, error prone. So each tag takes around 30 minutes to prepare and fix it on the sleeper. Now, and during tightening also, the spanner, they have to use the spanners. This will be demonstrated by Upendra after this presentation. Now, they have proposed, Upendra has proposed one additional modification in this existing design. Yeah. Here he had introduced 2 slots that are provided to the base plate. This is the base plate, and there are 2 slots that are provided to the base plate. Now this bracket is easily slipped through the slot that is provided here. And this is the new design which he has proposed. And then this stud also has a bolt that is welded to the plate here. So a bolt is inserted and tightened from only one side of the sleeper. Now the cycle time for preparing and fixing the sleeper is reduced by 10 minutes. As I told earlier, the total process takes 30 minutes. In this case, it reduces the time by 10 minutes. On overall reduction of 33% can be achieved. So, and the opportunity of error in reducing by using these nuts and new design is 83% reduction. So with this idea, with his idea, he can achieve a time reduction of 33% and error reduction of 83%. This is, now he will demonstrate by fixing one.
This is the older design, and here we are fixing 4 bolts and these clamps, and top side total both sides we are fixing the nuts completely, 2 places, and in our new design we have provided this bracket with a slot, and this mounting bracket clamp we can just slide it into the base plate. Just same side, both side we can fix it. And earlier we are using both side nuts fixing the bolt, and now we have inserted welded in the one side nut and we have taken a full long bolt, and we can fix it after putting into the sleepers we can insert the only one side we can use the spanner.
This reduces use of 2 spanners at the same time.
Only one side we can use. Same 2 sides. One bracket will come 2 clamps. These bolts we can tighten till the sleeper sides.
Till it gets completely fixed out of the sleeper.
Yes, sir. Thank you, sir.
Thank you for your excellent demo. And like at the end of the event, one can come and just see these things. Okay. So now we move on to page. Thank you.
Thank you so much, Translator sir. That was very informative demo. We request questions from our chief guest.
First of all, congratulations for developing this. This is again one of those things which looks simple after you see it, and that's why I think the demo is useful. But you just think about it, this would have been fitted for how long? RFID tags are being fitted on railway tracks. Is it a new technology? Are they fitting it for?
So we have been doing this for the last 4 years.
4 years.
Regular production. Earlier we had developed for a developmental contract. So regular production has been for the last 4 years.
But so for 4 years, is it by bolts or by what?
This is the board.
And in this one, how is that fitted? So the bolts are still required.
That is done in the factory.
Factory.
Oh, that is factory fitted. Okay, okay. So that is the difference. On the field, you don't have to apply the bolts.
These 4 boards can be avoided. That what is
It is still the same for both of them.
those 4 boards can be avoided.
Okay.
These 4 bolts can be avoided.
Right, and those are separate.
Yeah, this is the base plate, and this is the mounting bracket. So with the base plate, the RFID tag with the base plate comes fitted from the factory, and this mounting bracket and these are to be done at this end.
So my other question was that with the bracket, the new arrangement, there seems to be a possibility of some play between the legs and the top plate, right? Since it is.
Actually, the new one is more smart fit compared to the old.
Okay, that's because when you tighten it, it probably
Yes,
bends and.
it gets fitted with the sleeper. It goes flush with the sleeper.
Very nice.
One question. So what is the time to make that one and this one? So is it the same time?
No, this is reducing by 10 minutes. This will take
Not fitting, manufacturing.
Manufacturing stage.
The same time.
Is a
Manufacturing time doesn't play major role because that we give to an outsource party and we order it to an outsource party.
Delivery of
Installation part. Concern is installation, which is done at the site on the track where you have the high frequency trains or the frequency trains are running at high frequency and the installation time is to reduce. And second part is reliability.
Manufacturing time will be same.
It's the same. Yeah, if this takes more considerable kind of
Right, that's a very
what advantage you will get there.
that's a very important point to, of course, keep in mind. Just to, from my experience as a mechanical engineer and production engineer, that welded nut, for example, it is not a very reliable production process. It will probably be done by resistance welding, and the thickness of the metal there is not very high, so it will have. But these are separate problems. These are separate problems. The key thing, I think, is that you're focused on something which usually gets ignored, especially in a design center. What happens in the field? What happens to the person who is hitting it on the railway track? Exactly, it is not just a matter of cost, it's also a matter of the environment, the complexity, the challenges that the worker has to face there. And this is significant, I think, for those reasons.
The question is, on the old one you had those bolts, so that is actually sitting on the sleeper. So you have that gap out there, right?
yes.
So when it is sleeping on, put on the sleeper, so you have that gap for that bolt.
Yes,
What is with this? So there is no gap now.
No gap. Completely touching the
Holding on the sleeper. Right.
Yeah. Sorry, I have one more suggestion probably, because we have not discussed about this problem so far. Actually, I have an idea, just wanted to describe. Sorry if I am taking a long time.
No problem. So as of now, we are fixing it like this. This is the tag, and here we have a slipper. Here we are fixing like this, right? So which we need to do the fixing at the bottom of the slipper. So my idea is if you can make a bracket something like this. So if you make it as a bolt here, so it will be easy to access. You don't have to go to the complete bottom and use the tool.
the bracket, if you make it something like this,
That is a requirement, Sridhar. Putting it below the speaker requires
it is easy to install, and similarly it is easy to remove. It is easy to remove. We don't want that.
I thought it was easy to install.
It should not be easy to remove also.
Yeah, so theft is a very normal thing.
Thank you. Any other questions?
Instead of two brackets, can we put one single bracket to component?
One single bracket, gradually what happens is this may move to one corner of the sleeper. Okay, and functionality point of view, it should be almost at the center because the reader is placed on the bottom of the locomotive, is at the center. So gradually, not immediately.
Diagonally is talking about the bracket instead of two brackets, then you make one bracket diagonally. Understood?
Yeah, but you will not give fixing will be difficult and you will not give that complete square. This is easy. Any other ideas?
Any other questions or ideas? Okay, thank you, sir.
Thank you so much, sir.
Thank you for the demo.
Thank you. Ladies and gentlemen, if you want to get shocked and charged up in this afternoon, get ready. EDT department is going to take you on a ride to a watt-powered experience. Please welcome Mr. Ashok Bhupati, who is presenting on the topic named High Power Density Power Electronic Module Packaging. So what is this high power density? Is it Bruce Lee power modules? What is this packaging?
Yeah, now.
Ninja packaging?
Yeah, yes, it will be kind of.
Okay, all the best.
Thank you. Yeah, good afternoon, one and all. So this is Ashok Bhupati. So in morning session we just witnessed what is SIC and like I have mentioned about power density and all. So now we'll as I mentioned earlier, in EDT we have many power electronic components. So in morning session I have focused on DC to DC converter. So in this presentation I will be focusing on motor control unit. So I will be talking about how to densify the motor control unit, like how to achieve high power density. So yeah. So this is my presentation outline. So first I'll start with introduction, then this is kind of new topic which we haven't explored. So I just want to give an overview and what I want to share my thoughts. So next I'll talk about packaging fundamentals and techniques. Then I'll talk about thermal management, which is very difficult. Like right now we are facing a difficulty in doing that. So next is the design process, how to do the packaging and all. Then I'll conclude my presentation. Yeah, I hope everyone, all power electronic engineers, they might have saw these IGBTs, okay? So IGBTs were the key components till now, whatever we have done, so there we were using IGBTs. So if you see this, so this is an IGBT like single leg. If you see two IGBTs were there, so they were packaged into a single module. So likewise there are many packaging structures. So as we are an OEM, so original equipment manufacturing company. So we have our own application standard. So if you want, we already we have our specifications. So if you want to go for a power module, then we have to compromise there. Let's say if current rating is 200 ampere, then if nearby current rating power module is not available, then we have to go for a higher one and we have to pay price for that. So and there are many same kind of challenges were there. So not only so nowadays many companies, they are coming up with their own power module. So that we'll see how they are doing that. So first I will talk about what are the problems and challenges we are facing right now. So coming to a power module, so first one is power density, which I have explained earlier. So within the less volume, we should get more power. Then the second one is lead time. So nowadays we are experiencing this. So there is a huge lead time for the components for power modules. So if you have our own power module, then we can avoid this lead time. Then the third one is design control. So let's say if we are designing our own power module, so we can integrate the power module with other components that I will be explaining in further slides. So we have this control over the design of the product. Let's say if we are purchasing the IGBTs from the outside, then according to the IGBTs we have to do the placement and we have to package the motor control unit. So the next one is dependency. So we are depending on other companies, those who are making the power modules. Then the third one is flexibility. Again, it comes under design control. So we have a flexibility to make a product using the power module by our own design. Then the last one is cost. So coming to cost, let's say if we start making our own power module, our initial investment will be more. But once, since we are like at the starting, so once we come up with the one product, so it will be very easy to like the cost will also come down. So at the production stage. So yeah. So now everyone might have noticed this is the power module. This is how we saw the power module. So now I'll just quickly overview the what are the things, what are the components inside the power module. So if you see here, so first one is the semiconductor die. So the die is, if you see here, this is the die. So this is the main core component of the power module. So if you see an IGBT or a SIC or GAN, so this is the in crude way we can say this as a chip. So the next one is die attachment. So and then you have a base plate, substrate, base plate, interconnections, then encapsulation. So you have your die. So which you have there is a heat flux generated in the die when we are operating the motor control unit. So we have to take out the heat flux to the base plate. So in between we will have a substrate, and then as I showed earlier, in one power module you have two IGBTs. So there should be an interconnections. So you have the interconnections in the power module, and finally you should have an encapsulation material. So this outside black color which you are seeing, it is the encapsulation of the power module. So coming to packaging techniques. So this is the standard one, what we are having and what we are using. So if you see this standard packaging technique, so if you see here the silver color, so those are the dies. So if you see here, you could see 4 number of dies. So if our product is of high current rating, then we must parallel the die. So that is why we are seeing more number of dies here. So based on if there is a diode, again there are dies of diode. So then you have a gel over it, and then it is packaged into this. So this is the standard power module of IGBT which we are currently using. So the problem with this power module is, so if you see at the end there is a base plate. So there we will be connecting our heat sink, or there we will be doing the liquid cooling everything. So here you can do only one side cooling. Okay. So let's if you see here, there are 4 different kinds of modules. So this is over mold. So here you can see the dies were if you see this volume and this particular module's volume, these were drastically reduced. So I will be focusing on this double-sided direct bond copper. So here we can cool the module on the both sides, so that we can quickly remove the heat flux from the power module. So likewise there are other 3D power integration, then component integration, then overmold. Then if we classify the packaging techniques, so first one is the system integration. So where you have dies which I mentioned, which are the IGBTs and all. So as my colleague Kiran mentioned, you will be having a gate driver for the switch. So that gate driver we can integrate inside the power module. So that is one of the advantages. One of the flexibility we can have if we are manufacturing the power module from the die that scratched. Then the next one is PCB embedded packaging. So where the dies were embedded into the PCB. So this particular packaging will be holding for lower voltage ranges. So the next one is press packaging. So again the same standard this die base plate and all. So here you will be having a spring. There we will be pressing the controller and gate driver onto that. And the final one is 3D packaging. So here if you see this is a DC to DC converter where you have the MOSFETs, then planar transformer, auxiliary power module, microcontroller and all. So these all are packaged onto a single plate. So if you see here the MOSFETs are cooled on both sides and the transformer also can be cooled on the, like if you see there is a water channel into the onto the transformer. So this is how, like if we are manufacturing our own power module, there are a lot of ways where we can integrate all these kind of packaging things. So now I'll move on to the next, thermal management. This is the most important topic when we are going for motor control design. So we have ICBTs, we have gate drivers, everything we will mount and we will make the product, but the only thing we won't care about the thermal management. So in order to do that, so everyone knows that there is an air cooled where we will be using fans and heat sink. Then the next one is external liquid cooled, so which we are using currently, like using a cold plate. Then the third one is integrated liquid cooled. So you are cooling the die without having any this particular substrate. So directly you will be cooling the die. So here that you can reduce that. If you are manufacturing, if we are purchasing the IGBTs from the outside, we can't go for these kind of techniques. Okay. Then the fourth one is double-sided cooling. So which is more efficient. The same integrated liquid cooling will be doing on the both sides of the die. So this way, using this double-sided liquid cooling, we can remove the heat flux very quickly. So if you see, in our, when we are using these switches, we should have a less thermal resistance and more power density. So if you go this way, then you will be having more thermal resistance and less power density. If you are going this way, then we will have more power density and less thermal resistance. Yeah. So these are the few products which were made. This particular one is a double-sided cooling power module. So if you see here, there is a die inside, and you could see these are fins. So which were there on the both sides. Then the water will be circulated around it. So this is developed by Hitachi. So likewise, here also there are fins on the both sides. Then this is another way of integrating the power module. So generally when we purchase IGBTs for 3-phase inverter, we'll have 3 different power modules. But these particular companies, you saw it, they have integrated all inverter onto a single power module. So where the gate driver is integrated onto it. Then this is the most effective way of cooling the power module. So this is the power module. So this is tagged in between the cooling channels. So if you see here, so this one, these all are cooling channels, and the water will be circulated here. So the both sides of the power module will be cooled. So this, after doing this is how we will integrate the power module and cooling channel onto the PCB. So these are the gate driver circuit and other control circuitry on the bottom side. So this is one of the best way to do it. And there are other future cooling trends which are 2-phase cooling, where the phase change will happen. If you see here, this is your heat source. Then you have a vapor chamber. So inside the water will be there, that will be evaporated and condensed. So here, using this 2-phase cooling, we can quickly remove the heat flux. Then there are additive manufactured heat sinks and direct chip substrate cooling, so which I just mentioned the name so that we can just go through on those. So let's say, so now we have seen how to do the, what are the power modules and how to do the thermal management. So now we will see what are the considerations we should take before designing the power module. So the first design consideration is the size. So this is again volume, weight, power density. These are the things. The next one is electrical performance. So what is your product current rating, voltage rating, switching frequency range, power loss, electrical insulation and electromagnetic interference. Then the thermal management, which I have explained earlier. Then the mechanical strength, so some thermal stress distribution, material properties and shock and vibration. And the reliability and fatigue, so any crack propagation and joint failure, these all things we have to take care while designing the power module, and the final is the manufacturability and assembly. So I'll just quickly go through the design process, how we have to, let's say if we are as a HBL, we are let's say we are designing the power module, so we should start in this way. So first we should what is our automotive application requirement, then after that, so we'll see what is the electrical configuration. So where we will, based on our product, we will be selecting the bare die. Then what is the module topology we want based on our product. Then if the current rating is higher, then we will parallel the dies. Then we will do the preliminary geometry design, where we will select the materials, then the internal layer configuration, then in plane size and die location, so where we have to place the die in the power module. Then comes the thermal mechanical simulation. So this power module design involves both power electronics engineers as well as thermal engineers. So first we will be doing thermal mechanical simulation. So there we will check what is the temperature of the power module, what is the stress, strain and reliability study. So if it is not passing those criteria, that particular criteria, then again we will go to the preliminary geometry design. Then after that, if it is passing that, then we will go for the electrical design, where we will check the circuit tracking, interconnection and I/O terminal configuration. So again, after that we will do the electrical simulation. Then we will check what are the parasites, like we will check for strain inductance and all. So then what is the switching transient, then insulation. So once, if it is not passing there, then again we will come for the electrical design, we will do the titration. Then again we will go for, if it is passed, then we will go for terminal and housings. Then we will do the fabrication. Then we will do module level testing. So here by this step the power module is fabricated. Then after that we will check the temperature and reliability of the power module. If it is failing, then again we will go for the first step. So then after that we will check the insulation, switching transient and efficiency. So these two checks are for the module level testing. So if it is failing, then again we will go for electrical design. If it is passing that, then we will go for the prototype model. So our product will be doing. After that, we will do the system level testing. So this is the procedure. This particular procedure we will be doing. So once since we have started off doing this, so we will be following this procedure. And coming to the softwares, we are already having the license of ANSYS Fluent and ANSYS Mechanical. So with those we can do all these steps easily. And I would like to conclude my presentation. So packaging our own power module based on the application requirement gives more freedom than depending on others. So with the proposed idea, we can make a high power density power module with double-sided liquid cooling. So I am comparing our product with the Dana motors. So where they have power density of 10.93. So in our current product, we have reached up to 9, and we are next version we are trying to reach power density of 10.98. But why I put those why I just left empty, because so with the conventional way we may try to catch that power density, but there are companies where they were able to do 30 kilowatt per liter. So there they were going with the scratch, like they are selecting the dies and they are fabricating from the scratch. So as a HBL and as a OEM, we must start, since we are at the start, so we can start our product from the scratch, so selecting the die and doing the things. Yeah. So yeah, thank you for your attention. Thank you.
Thank you, Ashok. I request questions from our chief guest.
Yeah, thank you for describing this very nice development process of a new idea.
Thank you.
And new technology. You have not completed that yet, right? You are.
Yes, sir. It's like we are at the start. We are we are going to do that. That is also. So I just described how we are going to do it. So yeah, since we are depending on others as of now. So actually I joined 1 year back. So now we started up doing.
Yeah, so most likely this presentation will probably be worth seeing again next year and the year after that as things progress. And there will be a lot of things you'll probably learn and you'll probably be able to bring out.
Yeah, sure. I feel this particular project will be kind of one of my PhD thesis, one more PhD thesis. So what I noticed, and I hope all of you also noticed, that there are a lot of interesting themes in what you described. One of them is that how multidisciplinary this is. Most of you are electrical and electronics engineers, but this presentation brought out that there are thermal, structural, even thermodynamics. There's somebody mentioned phase changes, yes. And all the other disciplines, they come in and they all work together. And this probably also, somebody will probably realize that different organizations as well, or different kind of specializations work together. The die making is a specialized process. There are some very fine manufactured components, heat exchangers, and they are again a specialized process. Yes. And so different specializations in different organizations might come together. The companies that you saw, other companies mentioned, Dana and Medias, a few other companies whose technologies are outstanding, most of them have probably not worked alone. They have worked with the ecosystem of other specialists. You mentioned certain software. Those software themselves are specialized businesses, ANSYS and yes. such companies. So it's interesting to have and useful to have that sense that in a way it's an interconnected world. And most innovations, most great ideas, they come out when you look beyond your own capabilities and integrate the best things from other people as well. So you brought it out in this presentation, and I think it will help all of you to also apply that thinking in your innovations as well. Thank you very much. Yeah, any other questions?
Questions from the audience? So he is encouraging you to ask questions.
Is the time frame you are planning?
Yes, initially I thought of keeping the time frame like how I mentioned in DC to DC converter, but still we are at the like basic level, so I thought better I shouldn't false promise or something, so I thought that.
Best way of saying I don't know.
Any more questions? Right.
Thank you,
Mr. Ashok.
Thank you.
We have come to the last presenter of the day. Let me introduce to the human side of electronics. Please welcome Mr. Pradeep and Mr. Prabhakar Garu to present on their topic on intelligent performance management system.
Okay, the last presentation nobody asked questions, so it prompts me to ask if everybody is awake still. Good afternoon. Once more. Good afternoon. Okay, now I'm confirmed. You are awake. Alright. So I'm not going to talk anything new or anything innovative as such. I think everybody knows what performance management system is. You would have heard in your careers, in your lives, many times. This is, as you saw this morning, Vipassana sir presenting the 12 dimensions of innovation. So this is one of the organization process improvement innovation, is what I call it. We all have performance management systems in every organization. We do have a performance management system, but it's a manual system as of now. So we wanted to take it online, make it more interactive and improved system, and then continuous performance management system. Typically in every organization we see that we have an annual performance management system. Correct? Yes or no? Yes. Yeah. So we wanted to do something different. Again, this has come up as
in one of the discussions again, great chair of Vipassana, so when we started discussing how do we improve this process, so we thought we wanted to have this as a continuous performance management system and then take it forward. So we developed a portal, basically electronics group HR portal. So there are many things which we wanted to do, but we wanted to start slow and then take step by step. So there is, so first step towards this is a performance management system. So let me just go over what is performance management system. So I don't need to say anything new about it. Everybody knows what this is. So it includes 3 phases. Basically setting expectations for employee performance and then maintaining a dialogue between supervisor and the employee to keep performance on track. So most of the time this is the forgotten step. And then measuring the actual performance relative to the performance expectation. So the point number 2 is most often a forgotten step, so we hardly interact with our employees, and then there is a huge gap when it comes to the expectations of the employee versus the performance. So why measure performance? Because what you cannot measure, you cannot improve. Agreed? Yes. Yeah. So if you cannot improve, you cannot grow. True? So measurement helps in objectively differentiating between performance and non-performance. So we often see that, I mean, as I think many of them here are supervisors, managers, so you have people reporting to you, so you often see that there are always some disgruntled employees. True? Yes or no?
No matter what.
No matter what, yes. So how do we, overcome this? So why do we need this? So right now at HBL, what we have seen is mostly, our performance management system is an annual performance review, and it's right now a manual process. It's a paper-based process, if I'm not wrong. So most of the time, and then when we actually, the regular work process, when we actually set the KRAs, most of the time you see that they are actually reporting their regular work process, right? What they are doing immediately, but eventually those whatever KRAs have been established, they are not in turn connecting to the department objectives and in turn to the organization goals. So there is no correlation between organization goals and then the department objectives and the KRAs. So this is very often seen. So have you experienced something like this? Most of the managers and supervisors here, yes or no? Okay, they are silent. So, and there is no transparency, nor proper justification on individual performance rating as well. Manual process assessment is also quite time consuming. So this is the reason why we wanted to have something which can be more interactive, more oftenly done, basically on a quarterly basis. So we thought we should have something called online performance management system. So somebody said that to be effective and yield results for your business, performance management must be year-round process with no end. So obviously, we cannot do it every month. So we chose to put it at every quarter. So this will be year-round process, and we would like to make this as a quarterly process right now, and see how this would evolve as. So next, to have an effective performance management, so employee owns the process, the supervisor is actually partner in the process, HR will support the process, and then leader is a champion the process. So I think everybody understands those 4 dimensions. Yeah, those 4 dimensions. So I think we all are, most of them here are supervisors, we have employees, then HR and leaders. So everybody supports this process. So it's like kind of a coordinated effort. It's not like an individual effort or just the supervisor and the employee doing the things as a performance manager. So everybody is involved into it. But these are some of the steps. So it should be ongoing process of setting expectations, executing plans and evaluating results. Then expectations should be explicit and mutually understood. Engagement is increased when people are involved in planning the work. Then how work gets accomplished is as important as what gets accomplished. So regular honest feedback increases understanding and positive performance. Okay, I think most of the time, we almost know everything, but we don't implement it. So this is often seen. Next. So to overcome all those what I have said just now, we have introduced this portal as I said. So this is how it looks like. Unfortunately, the internet connection seemed to be pretty slow here. So we wanted to do a live demo on this. We started this application and this is now ready to use. We actually introduced this as a trial version right now. I think some of the managers have already started putting into this system. And then we were seeing what kind of errors, what kind of issues could come up, and then as we are improving on it, and we want to make sure that from next month onwards we want to go live with this particular product. So we have this. This is the portal. We have the login. And next, as a first step, so you see many of the other items in portal. Right now we have enabled performance management. So you see performance management. Click on your performance management. Then the first thing you see is a dashboard like this. For each and every employee, you have a dashboard, and so you see your reporting, your status of your supervisor. So this is my login, and I can see all my report is also been shown up in here, and my details up in there. Okay, next. So the very first step after entering into this is to have an organization goals. So we have an yearly organization goals defined by the head of the business, basically using the performance management system. So in our case, Vidyasagar sir actually sets the goals for the year, every year, for entire organization, for the electronics division. And that is the starting point that triggers everything the moment goals are set into the system. Thanks.
I think after all the general managers agree.
Of course, yeah. So once we have the goals into the system, now all the department heads are expected to set the functional objectives, set their functional objectives based on the goals. Okay, so the moment they log in, this is the first screen what they see. Do you wish to continue with the previous functional objectives if they have already entered functional objectives for the previous year? If you don't have, then you will not see that option. Then do you wish to add, modify previous functional objectives? Go back. Yeah. And do you wish to add all new functional objectives? Since we are saying this is going to be a quarterly activity, you may have achieved all your functional objectives for the quarter if you have achieved. So if you have not achieved, you will continue with those. If you have achieved, you can always have an option to add new functional objectives as well. Okay. Then how do you create a functional objective if you want to add new functional objectives? So this is the screen here, so you would put all the details of the functional objectives for the respective goal. So after you add the functional objectives, so this is how you're going to see, so your functional objectives are aligned with the goal. So you see the goal there and then the functional objectives and then what is the plan of action, who is responsible to do. I mean indeed you are the one who are responsible to do and then the target dates, etc. and all. So now you are aligning your functional, your department objectives to the goal. So this is the first step. So all the supervisors, all the managers are aligning their objectives to the goal, organization goal. Okay. So this is the first step. Now comes to the second layer. Now all the objectives have to be aligned to the individual KRAs to your respective teams. So we'll go to the next. In the dashboard you see all these activities in here. So now it's a self, you can view your self KRA. So once you have a goal, you have objective. Now it's time to define your KRAs. So your KRAs, the supervisor, you can create a KRA for your reportees, your direct reportees, and your supervisor will create KRA for you. Or he can give you an option to create your own KRAs as well, which will be meaningful, and then at every stage this will go for an approval cycle. So it goes across the approval cycle where if you are adding your objectives, then it will go to your supervisor for approval. You both mutually agree, then he approves all the objectives, so that becomes the final objectives for your team. Okay, the complete team. Like in case if I take an example of production, so if Mr. Sudhakar's objectives are approved, then all his team members will see the goals and the objectives for his department completely, and all the people under him can have can have the KRAs fulfilling those objectives. So the next step is, you can create your KRAs, you can add KRAs to your direct reportees. Then you have an option to edit as well, so you can edit your KRAs. So go to the next. Now comes the self-appraisal. After KRAs have been added, then there will be a self-appraisal system for the individuals. So you can add your self-rating, and then you can give your accomplishments, what all have been given. So you will see that there is a goal defined and the objective for that particular goal defined, and based on that objective there are KRAs defined, and that KRAs are now in turn being addressed by the individuals, and the individual have to fulfill that KRA, which in turn is fulfilling the objective, and the objective in turn is fulfilling the goal of the organization. Okay, the chain would fall in place automatically once we have the system in place, and then you give your self-rating, then it will go to your reporting manager. Reporting manager would have his rating with the remarks, and mutually both of them agree, then you will have the final report. So this is a transparent system, everything online, and each individual can actually see what is happening at each stage. They can go back into their self-appraisal system, they can see if it has been reviewed, or if a reporting manager has already given his ratings, etc. and all. So it's a transparent system as of it goes. And you can print various reports as well from here. You have your appraisal report, you have goal objective mapping report, and then objective KRA mapping report. So it gives the details of all the report. It can be downloaded and it can be exported as well. Okay, so that's about the tool. And who doesn't know the management guru Peter Drucker? I guess everybody heard the name at least. Right. He rightly says the test of an organization is not genius, it is its capacity to make common people achieve uncommon performance. Agreed? So, last but not least, what are the benefits of having this to the business? So, provides a structured process across the organization, and every individual is absolutely clear of the purpose and the goals he is working for. Many a times we hardly know what's our organization goal. I mean, it used to be, I'm sure I think it is still the same, but with this system, I'm sure everybody will now know what the organization goal is. And leading to motivation and job satisfaction also. So they know that they are working for a purpose, definitely it gives a lot of job satisfaction. Continuous performance management system drives the growth of the organization, and then provides various reports for management to make an informed business decision. If some of the objectives are not being met, then management has that informed decision to see how they can set the goals for the next year as well, or maybe even within the year if we need to pick it up. And improves employee retention, then saves time and money. Last but not the least. All right. Thank you. That's all I have for today.
Thank you. Now we welcome questions from our guests.
So, if you don't mind, I'll just challenge you and ask you to tell us how does this tool relate to today's activity as innovations, organization goals, and individual goals. Will it map to this particular activity?
It falls within the 12 dimensions of the innovation what we saw as an organization process improvement. So if you recall the 12 dimensions of the innovation what we see. So as a process improvement for the organization, what are the different things? So end of the day, we are talking about process improvement for the organization. So what is it that we can do to improve the processes within the organization? How do we do that? So the satisfied employee and the a good performance of the employee will definitely boost the organization morale as well, and then increase the profits for the organization. So not directly but indirectly it would help the organization when we have a proper performance management system in place. So that's the whole idea of it.
Questions from audience?
Yeah. Any more questions? Since this is our last presentation, I request the attendees to ask questions.
Pradeep, there are other modules also. I think
What is happening is the existing lead management system which we are outsourced from them, there are some problems and our team has to depend on them. But now I think if this is also done, all is one place, then we will be good.
Well, yeah, I mean, if you all cooperate making PMS successful first, so based on this, the next one comes.
Actually, to add on to the response that you gave to Amitabh, we started with the intention to manage competencies. Actually, that's how we started 2 years ago. And the intention is to go with a PCMM certification, people capability maturity. In fact, if you have seen that portal, go back to that portal, opening page. Yeah, there. So you have this competency management. That's where we started it first. Then we realized that we can't have a good competency management without having a good performance management system. So we parked that topic and we focused on the performance management. Once we have this in place, then we will go back. So that's how, yeah, it is actually 2 steps forward, 1 step backward, but 5 reasons.
Yeah, any more questions?
I knew they will not ask.
Thank you, sir. Thank you very much. So now we have completed these presentation sessions, but this is not the end. This is the beginning. We still have to know who is the winner. Now I call Mr. Pawan sir to lead the next session of the activity.
Thank you, Tejaswini. Thank you, Ashok. And thank you, Pradeep. That was an amazing presentation. It is like zigzag for the last bar. We have completed 2 sessions, the opening ceremony and the second one is the presentations. Now, before we move on to the third session, that is, everybody is waiting for the prize distribution. Let us take some time, the jury will take some time to review all the scorecards and we will come back with the final scorecards. There will be 5 winners among 16 presentations, 2 from the poster track and 3 from the PPT track. Okay. To keep you occupied, my colleagues Ashok and Prabhakar will organize some games for the next 15-20 minutes. Then we will see you all after 20 minutes. Thank you.
Do you know that? Sir, it's indoor game, so you can sit at the place where you are sitting. So no need to move. We are coming to you and making you play.
We need to divide you all people, a team of 5.
Yeah, team of 5. Each table should have 5 members.
And you are going to play with pen and balls today. So please divide yourself to a team of 5.
So those who are winning the game, they will get very good prize. So interesting prize. So
this is a challenging game. You have to lift the ball with the pens.
yes, sir, we are showing the video. So
The video is playing.
instead of saying the game rules, we just show this.
We will not say any rules, but we should not break the rules.
Yeah. Demo. Sorry, we are giving demo. Visual demo.
So like that, we give you a ball. I don't say.
So this is 10 ball challenge.
You should not take the grip of the ball with the hand.
Yeah, only pens.
You should hold it only with the help of pens. If anyone drops the ball in the middle, they have to restart from the first.
If someone wants to stand on the table, they can. Yeah, we are distributing the material which you can. Since this is an innovative conference, you can use your innovative ideas. Not only so the table is ready with the innovative idea.
You can come and place the ball on the table.
Very good. Yeah, you have to bring the ball till here. There is a cup here. Whoever brings first. And one more thing, there shouldn't be any manhandling. So teams will come out. See, the last table they were ready for manhandling. So better. One should be careful from them. Sorry. Once again, I am saying there is an interesting prize with us. Whoever wins this, they will get. So I hope everyone received the pens
Yeah.
No single man show, you have to be, it is a group performance.
So now time is 3:45. I'm giving you 5 minutes. Yeah, we are giving. Just wait. So meanwhile, you think how to do a teamwork, okay? No, you just think of strategy. Meanwhile.
Hope everyone got the balls and pens. No, we didn't get it.
No, someone is touching with hand there. That team is cheating. Why also you have to start from there. No, I saw the cheating. Come, here. I will touch. Come. No, come here. Even I didn't say this. See, now 3:46, we'll start at 3:50. Yeah, you can start the game. Now, you check here. Something is happening here. We don't know where to be. We are not telling. How many? Yeah, we'll do the second round.
It's just a demo. The actual game is not yet started.
Yeah. We are done with demo, now we'll start the game.
That was a nice demo.
Yeah. So I hope every team practiced till now. We'll start the game in 5 more minutes.
Okay.
Yeah. Okay, we'll start one by one. But you shouldn't destroy the ball. That is the first rule. Yeah, you must. Even you shouldn't manhandle the ball. Again, one more rule. Yes, sir, they punctured it. Yeah, we'll go by team 1, 2, 3. Yeah, now we'll start with.
Can you all please be settled?
I request everyone, please be seated. We'll start the game. Yeah, once again, I'm requesting everyone to be please seated. Okay? Yeah. So I'm numbering the teams. 1 minute. Game not started. Mr. Tindakar, you can go back. No, you can go back. Yeah, now. So now we are giving 2 minutes. Yeah, now we are giving 2 minutes to each team. Okay? Yeah, one by one. Yes. Yeah. Come. Yeah. I request team A to come here. Come here. Everyone come here, please. I hope everyone can witness the team 1 game. They are going to start. See their teamwork. Just 2 minutes. Yeah, from here everyone will be coming on to the first table. You should use only the pens what we gave. No pencils. Even like
Wait, we haven't started.
They didn't touch. They now started touch. Come back. Again start. Sir, we will be calling everyone there. Because, yeah, you can practice on it. No.
Yeah, come on, nice strategy. But you're touching the dais. Check. No. Other teams will be disqualified. Team one, they did it in 4 minutes. Yeah, they took 4 minutes. And 4 tries. Yeah, now I request team 2. This particular so you must use whatever you Yeah, this team, they are trying to manage Yeah, you already lost 1 minute. No, we are going to start. 1, 2, 3. This is the first rule. Only use tip of pen to lick the ball because tip 1 they have already used it. So now you can go with your own strategy. But you shouldn't capture the ball. You shouldn't manhandle anything. This particular this particular manhandling is This particular manhandling is disqualified. Yeah, you shouldn't leave.
Team B is officially disqualified.
Yeah, they are banned from the Vipassana.
Games, Vipassana games. There is a small correction. Vipassana games.
This particular team who disqualified, they are manhandling the post. They are threatening the post.
Team C is starting.
Yeah, come on. 1, 2, 3. Yeah, 1, 2, 3, start.
Team C is taking time.
Yeah, we already started. They lost
the ball and they are missing the ball. They couldn't flip the ball.
Seems like there is no proper teamwork in the team C. Yeah, team C should go back again. They have to start. You must think how to do. You should have a teamwork to do that. Now you should use only one hand. They are using 2 hands.
Team B is cheating.
Man-handling team should be banned from Manika Villa, I hope.
We are the winner.
So you took this goal. What is this? Mr. Tinjaka took the goal. I hope.
Ball kavala?
It's 1 minute 22 seconds. We still have 40 seconds left.
We have this demo. Come on, Team C, you already lost 2 minutes. We have 1 more minute to do. Yeah, they are going with some strategy. I hope they will reach. Come on, Mr. Siddharth, show your teamwork here. Come on, Siddharth. Yeah, you can put it on the table.
Yeah.
Team B has started the game.
No, sir, you are not using your team member, sir. Right, sir. You are not involving your team member. Come on, sir. I hope you have a strategy to do that. Sir, you should have proper teamwork now. Come on, next round. No, sir. Seems like Peter is calling everyone in the hall. Come on, sir. Team whoever is about to complete the No, they are not. Yeah, nice way of bringing the ball. Yeah, they are about to finish. Yeah. On the table. Yeah, nice one.
Team B to 1 minute 14 seconds.
But where are the 10 minutes over?
1 minute 14 seconds.
Yeah, next team, please. I hope something they may finish it in 1 minute. We are expecting that.
Team E should challenge within 1 minute 14 seconds.
I couldn't see any innovative idea in the game.
You didn't allow it. You didn't allow that.
Alright, ready? Come on.
Team E is challenging Team D. And they scored again 24 seconds to keep the ball. 24 seconds. 24 seconds Team E.
Without any strategy, they are able to finish it in 30 seconds.
That's great actually.
Yeah, next team. Yeah, start.
10 seconds. 5 seconds.
Even hands very only.
Disqualified. You cannot hold 2
That is also good.
Only one person.
So I asked only innovative ideas, not any cheatings. Yeah, next team. Yeah, all interns. I'll see how these young people will destroy the ball. Sir, you have to use only one pen. Yeah, now interns are about to start their game. Let's see how they are going to end up. Start. No one should touch the ball. If you touch, you have to, yeah. No problem. I think you should rise again and you will do that. Yeah, no, we won't do that. Yeah, what Mr. Pawan, I couldn't see any young energy in this. These young people must complete it in fast, the fastest possible way. Miss Kaleshwari does the ball, they should come, go back and, yeah. Yeah, this team unknowingly cheated, so they are disqualified. That is what unknowingly you cheated. So, yeah, next team.
10 seconds. 30 seconds. Do it again. We will do it again. Just that is good.
Okay, we are finished with the first game. Now we are going to have the second game. Those who couldn't make it, now I hope they can win this next game. Particularly this man-handling team must be able to. Yeah, this is the next game. Pyramid challenge. This is the next game. So we will be giving that 5 threads. So like that you have to bring the cups and you should make a pyramid. I hope this game is very easy than the previous one. Let's start it. No. Everyone did. Ladies were able to do it in 41 seconds. Let's see. They set the target. We'll see how fast we can reach that. Yeah, who are going to take first?
Come here. We need 6
ये बहुत मुश्किल है क्या रबर बैंड लगाया आगे रबर बैंड 2 4 1 2 3 सारा सारा एक को दिशा लाहे
I think you both did participate. So you fight and make it already participate. What this man-handling team is trying to do? So I hope everyone could see the video. This is a pure team go game. Yeah. So we need how many? 6 members. So I request 3 more. I think man-handling team can participate in this. Mr. Divdalkar, you shouldn't destroy the thread. You shouldn't squeeze. And one more thing, you shouldn't squeeze the top. That is another rule.
That is what, you shouldn't squeeze the cup. You can do whatever you want, you shouldn't squeeze it. So, I think yeah, one thing, you shouldn't squeeze the cup, okay? You should make a pyramid. So you have total 6 cups. First you keep 3, then keep 2, then you shouldn't touch with the hand, Mr. Tirthankar. Yeah. No. Second should go back. You must use rope. Even you shouldn't touch the glass. You shouldn't touch the cup. Again. Okay, you already violated twice, so I am giving one more chance. Since you could play well, so I am giving you a chance to do that. Yeah, it was a nice teamwork. They were in the second level. Since Tirthankar is in a hurry, they lost. All managers are instructing Tirthankar to be cool, but he is unable to hold this. Yeah, they did it in 1 minute. Okay, this was the next thing. Right. Players are already moving the Mr. Siddharth will lead the team. Siddharth, where are the 6 people? Sorry, already. Yes, already people has come. He must be fast. No. Others shouldn't disturb their teams. See, these manhandlers, they are spoiling others. No. First time I was handled is Tirthankar. He's destroying everyone. Left, yeah, Mr. Kiran is leading the team. Let's see how we will end up. Kiran is instructing, but the team is not at all listening. Kiran is coaching in all possible ways, but the ladies were not at all listening. Kiran. Those who finish the game, they can go for tea and coffee. Yeah, seems like they are doing well, but they are doing late. I hope it shouldn't collapse, or it is going to collapse. Seems like it is going to collapse. Somehow they have managed to keep. Yeah, it is 1 minute 5 seconds. Yeah, next team. Subramaniam sir, your team.
How many minutes they do?
1 minute. Yeah, those who finish the game, they can go for tea and coffee. So you need one more. So now we will see the experienced team. We will see how they are going to do. I am hoping they will finish it in 10 minutes. Sorry. 10 seconds. Yeah. Yeah, they are going to start. Let's see how they are going to finish the game. Seems like Subramanian sir is doing it with ease, without any difficulty. Yeah, one hand only. Yeah, they are using one hand. See, this is how the experienced person will play. I hope the interns should come and learn how to play the game from the experienced people. See how they are doing it proper. Oh, sorry, they lost one cup. They have to do it with thread only, yeah, with rope. They shouldn't use the hand in any case. Now we'll see how they are going to lift the cup. Subramanian sir is instructing them to lift the cup. Let's see how it is going to. Yeah. So it is no. So they were sincere enough, so I'm giving a chance for them. That is what I'm saying. Cheating versus sincerity. Let's see how the real innovation comes into picture. Mr. Kiran, you are destroying the other team, I think. It seems.
Don't disturb.
Oh, nice to hear. You can try that. Nice one. Wow, excellent. Yeah, I will. Yeah, now they are going to be in third level. Yeah, yeah, excellent.
8 seconds. 2 minutes.
Yeah. Even though it is 2 minutes, that it is with sincerity and yeah, that is what I mentioned from the starting. I think I shouldn't say it again. Next, the intensity.
Start and we're checking out to start.
I hope you can. Yeah, I will be very much serious. Let's see the other team how they are going to do. Yeah, start. Akhil, we can start the clock. Yes. Sweta is instructing the interns team. Let's see, they are not at all listening things. No, where you people are going? Where? No, I didn't ask you to go to Tumbuta Lab. You should be here in Alikuta. Pawan is holding Sweta. Yeah. So now Rachana is seems like college again. Pawan is holding the girls. So he's giving full freedom to the youngsters. Yeah. They are done, they are about, yeah, they couldn't make it the second cup as well. Yeah, you can throw them if you want, so that you can be disqualified. Seems like this intensity must practice this game at home. I don't know how they are going to end up in the second level. The first cup is itself is far from the second cup. Let them use, I don't know how they will do it there. Let's see how they are going to end up there. Yeah, now Pawan has a particular idea, proper idea, but still. Now Pawan is about to scold everyone in the team. Now you shouldn't touch. I already gave enough. We must encourage them. You shouldn't touch with hand at any case, any cause. Miss Rachna is having a particular idea, but others is not supporting it very. You have threads with you. Yes. Come on. Seems like they are going to home at 8 p.m. or something. These people are going to play for Anna. Yeah, you have last 30 seconds. Yeah, that is your last 30 seconds. Yeah, somehow Rachna did it. Let's see how they are going to. Now others must support. No, you should be slow and steady. Yeah, very good. Keep it up. Now you can. They are doing all possible wrong things in this game. I think. Yeah. Now I think you can carry on. You can go for tea and energize. You can come on again. Enough. Yeah, very good. Clap for them. Next team. D. I am expecting Vipassana's team to be here. Sir, we team like last time chala baga. So I am expecting it in 10 seconds. So then with one hand you can eat samosa, other hand you can like egg. Yeah, Akhil is having an idea. Come here, okay? The innovative idea. Yeah, Neeraj came with samosas. He is trying to rewrite the game. Oh, something you are going to do. Very good. He is having again innovative thought with pencil. Now he is going to play with pencil, samosa and cup. Let's see how he is going to. Yeah, you can bring that as well. Still, I am expecting Vipassana's team to be the winner, but they were not encouraged enough to play. They gave up. Seems like Sir is not in the hall. Team Siddharth supposed to play, but they ran away from the table. Yeah, now everyone can enjoy their tea and samosa. Yeah, I would like to know who is the youngest in the room. Then you must say your age as well. I want to know who said that no way answer. I will give to them. No, you must have hard copy. I'm having it. Yeah, combined photo. Yeah, that is what. Say. So, for this question, Richard sir got the prize. Sir, you said no way, right? So, that's a good answer. No way. So, wanted to know who is carrying his white photo on the bus, in the bus.
Hard copy, no one will have now. Hard copy.
Yes, sir, hard copy. I thought you were saying from the heart, so.
That copy is always available.
Mobile screensaver. No, sir, only hard copy.
I'm checking it.
Seems like many people are carrying. Yeah. Yeah, I think Akhil must carry his right photo, but girlfriend's photo. But he is married, I think. Sir, I couldn't recognize who is the person. So it's time to distribute the gifts. So which is nothing. There is So I'm starting with Richard D. sir for his excellent answer. Yeah, it's good. Those who are having their wife's photo in the birth, they will be getting 2 chocolates. Yeah.
Who are not carrying
So you are having naughty ideas. So all naughty ideas. Yeah. Akhil wants 10 chocolates, I think.
There is a suggestion to you.
She is not married, means she should get half chocolate. You can share one. And you should have 1 chocolate. Wife and husband should eat that chocolate together. Then he should get 1 chocolate. He can't share many. So are you right?
Hello, good evening. Now we came to the last stage of the event, that is prize distribution. But before declaring the winners, here we have some surprises in announcing the winners. I would like to invite our chief guest, Mr. Amit Chaudhary, to give his speech on this occasion of our annual innovation year. These are all the
Thank you. So, it was a very nice day for me today. I had a front seat and so many wonderful presentations, so many interesting stories of ideas, insights, innovations that all of you have done. How did you feel? How was your feeling? I couldn't see all of you, so I'm just asking. The audience here, how did you feel?
Very nice.
Nice. Energized? Yes. Yeah. My feeling, I'll tell you, I was feeling a sense of envy. I don't belong to this team. I work in a different company, and it was very, very admirable to see the amount of enthusiasm, the amount of engagement that all of you had. I think the audience is not just the people who presented, right? There are some of you who were and the involvement, the engagement that you had, and the other thing was the width of the diversity of the presentations. So this is HBL Electronics Solution. I know your company for a very long time, and know and admire you as a very technical company. One of the questions somebody recently asked me about HBL, what are the foreign collaborations? And I didn't know, I couldn't answer, but your chairman answered, and he told that there are no foreign collaborations. All the technology, all the great products that HBL makes are Indian technologies. So that's admirable. That's very rare. And at the same time today, which is in a group of technocrats, technical innovators, there are beautiful, innovative ideas coming from so many other functions, from finance, from HR, and that's another thing, that the team across functions is a single team, united team. There are diversity of skills, diversity of specializations, and that's the thing that is really admirable and enviable. So it's very nice to be with you, spend the day with you, seeing your ideas and your energy in presenting them. Really wonderful. Thank you very much. Now, one of the next things is going to be about prizes, winners and things like that, and this is really a part which I find very challenging. I was supposed to give some ratings and things like that. The organizers helped me by putting nice sections, technical content, presentation, clarity of speech, and so on. So, I could at least put. But one thing I wanted to tell you, that this is, when you, for example, watch the IPL or some months ago it was the World Cup, somebody won, somebody got the first prize or the awards and all that. But the best matches, the best catches, Rinku Singh ne 5 sixer mara, that was not in the final, that was not in the, it was in the process, right? In the event. And so it's been the same thing. The presentations were excellent all throughout. Some of you will have awards and certificates, but there was not a moment in the whole day. I spent the whole day with you, and not a moment where I was feeling bored or distracted. Every one of the presentations was very engaging, very interesting, and really, I mean, the time was a limitation. I would love to hear more from you and ask you more questions. So again, congrats to all of you for doing that. One of my biases might have played a role there, that it's about innovations, about ideas, but one always thinks that one can have many ideas. I have dozens of ideas, all of you have many ideas, how to make our country better, how to improve the traffic, and so on and so forth. But implementing them, executing them, getting them done, that's another big challenge and probably a bigger challenge. So I hope I managed to stay along the guidelines that the organizers gave me in terms of the ratings. But my personal bias towards implementing the idea, that might have crept in. So please pardon me for that. There were some brilliant ideas, and there were some wonderful executions as well, implementations of ideas. So I might have been slightly biased towards the second set. Right, what else? Well, that's about it. So please, go ahead with the rest of the day's events. And thank you very much once again for.
Thank you, sir. Thank you for your valuable speech. So just give us for 2 minutes before we set up the stage for ours. I would also invite our President, Mr. Vipassana, sir. Coming to the poster track, out of 6 ideas which we selected for the event, these 2 awards, the winner award and the runner award, as I got a story, at the end of the time, for the submission of the PPT for the abstract, they wanted to, take a backside whether we can do it or not. But ultimately, today they have won the winner award and the runner award in the poster section. So, in the poster track, the runner-up award goes to, any guesses which division? Sorry? Accessories Division, Business Unit. Yeah, correct. So I would like to invite Mr. Sridhar and Mr. Shankar Rao to collect the runner-up award.
ఇది పడుతుంది కదా కొంచెం సరే ఇక్కడ చూడండి సార్ థ్యాంక్ యూ
So, in the posted track, the winner award, again, it is going to the TICAS division only. And it is being presented by Mr. M. Srinivas and his team member Rajani Shah. Till now, all the awards have been gone to TICAS business unit, but the next award, which is the first runner-up award in PPT mode, is going to EG, which is presented by Mr. Pradeep Tongala for his performance management system. The jury has decided to give 2 awards. The jury has decided to give 2 awards, the chairman award for 2 persons. Let me call the winning teams. And out of these 2 teams, one team is actually got entry into Vipassana 4th event as a wild card entry. You know, after the submission of all abstracts, this entry has got the wild card entry, and they stood as the chairman award for this 4th Vipassana event. Which is the wild card entry, I will inform you. That is the demo which is presented by Mr. Upendra. And the chairman award is being shared by one more person who was actively involved in this event from today morning to evening. So let me welcome none other than Mr. Ashok Bhupati. High power density power electronic module packaging, which Tejashi was saying that ninja packaging. So congratulations to both of you. Request to Chief Guest to please
So we can close the event, right?
Yes, sir. So I would request our President Mr. Vidyasagar sir to give the order of thanks before we close the event.
Thank you, Pawan. So thanks to all of you for enduring the day.
Thank you.
And doing so willingly and pleasantly. I'm not sure if I should say enduring the day, enjoying the day. This is a busy period of the time for us, especially in the electronics group. 30% of our employees are in the TCAS business unit. We have about 330 employees and 120 are in TCAS. This is the most challenging period of our time in the execution of these TCAS projects. And every day, every hour is a stressful, challenging period of time. For many of you in the TCAS business to have come here and sat through the whole day by making sure that work happens elsewhere is I must say, it's a commendable thing from all of you. And those in the ETT, the electric drivetrains business, they have the challenging goal of making this 35-ton truck by the end of June. They have to assemble and make a 35-ton truck ready for road trials by the end of June. That's also a very tall task. And many of you are from the ETT and have come here to spend a whole day. It's not an easy thing to take one day off from that schedule. It's not easy. Thank you all for your enthusiastic participation in today's event. I must thank all the people who have competed with their innovative ideas, because it would have taken a long time in preparing for today. Coming up with the ideas, then making them understandable to all of us through the presentations and through all these posters. Should have taken a lot of time in preparation. Big thank you to all of you who have competed in this event. I was not sure actually. We would normally be conducting this event in February, March. I was not very sure whether this year we would be able to conduct it, given all the challenges that we have in the execution of the projects, both in TCAS and, I wouldn't say TCAS, in railway electronics and ETT. So this was a decision that we took in January, so it took 4 months of preparation coming to today's conclusion of the event. And Pradeep and his team of organizers were doing it in the first 3 years. And since they were all heavily involved in the TCAS projects, so we looked for another organizing team. So this team started working on the conduct of this conference in January. I think they have done an admirable job. And maintain the continuity of that tradition. And Pradeep is not an easy guy to be emulated. So the new team has taken it to another level. So thanks to the enthusiasm of some newcomers of the team. Tejashwini had been a great MC. In fact, I was joking that I don't want her to take up the job of a TV anchor. It's too critical for our TCAS project, so we should be using her from the role of TCAS. Okay? It's been a tremendous day. I personally enjoyed being here. And to Amitabh ji, a big thank you. You are, handling some very prestigious and challenging projects at this moment, and for you to take time off from those engagements and be here with us for a full day. Thank you so much. I'm sure you found the time worthwhile, as I mentioned this morning, and your engagement with all the participants and your probing questions. They were all well received and thought-provoking. Thank you so much. I was not expecting this kind of an engagement and interaction that we had. given what you said in the morning, that you are a mechanical engineer and most of our topics are related to electrical electronics. But the questions that you asked reveal your humility. You are a full engineer, not a mechanical engineer. So I was very pleasantly surprised by your humility, like all the accomplishments that you have in your life. But you are saying I am a mechanical engineer, but I didn't able to understand. But at the end, you were asking all very thought-provoking questions. Thank you so much. I have to now thank Pawan. Yeah.
We wanted to hand over the checks to winners.
Oh, okay.
So I would like to invite again all the winners to just collect the checks. Mr. Ashok and Upendra.
సైడ్కి మొత్తం అది కనిపిస్తుంది కొంచెం కనిపిస్తుందా ఓకే డన్ డన్
Mr. Pradeep Bongla and Kavakar.
అటా
Mr. Srilata and Srilata.
థ్యాంక్ యూ
Mr. Sridhar, you can collect one more check from us. And Mr. M. Srinivas for the postal award. Thank you, sir.
Right. So, thank you to Pawan, Tejashwini, Ashok, Prabhakar for an excellent organizing of the event. Richard, sir.
My pleasure, sir.
Sridhar. So, all of you have done an excellent job in organizing this event today. It's been a lot of hard work. So I want to record our sense of appreciation for all of you through these certificates. So, with all of you come together. Come. On?
Turn the certificate.
Does it come? Yes.
Turn your certificates towards the camera. Turn your certificates towards the camera.
Certificates, sir.
Mask.
Close it.
One second.
One second. One second. Thank you.
So before we close, before I say the last word, a certificate of appreciation for Pradeep and Sindhu for the 3 previous conferences that were organized, but I believe we have not recognized or appreciated on the record. Yeah. Thank you all. Thank you so much. Right? So we can go home.
Don't forget your video
Yeah, we are done with Vipassana 2023. Hope we will be seeing you people in Vipassana 2024 soon. Now, more participation. What is the bit?
I didn't say anything. I think it's targeting somewhere or the other. What